Hello everyone. Azure AI Connect 2026. Let me change my background. I hope everyone is doing great. This is our last day 5 of our event, and I'm truly grateful for every speaker and every creator that joined our um, our event here. I'm truly honored to have such expertise around for everyone watching. We are broadcasting live in YouTube, but also all the sessions will be recorded. Without further ado, I'm going to bring on stage George. George who? I'm pronouncing it correctly, I think. Hello, George. How are you, my friend?
Good morning. Are you able to hear me?
Of course, we can hear you. So, where are you located right now?
New York.
New York. Okay, so it's morning there, all right?
Yeah, it's morning. It's a great day.
Okay. What are you going to tell us, George? What is your topic for today?
Yeah, I placed in the chat room. I will introduce accelerating data workbench automation
Okay,
with agentic AI and AI Foundry.
amazing. Perfect. Do you want to share your screen so I can add it to the
Uh,
stream?
it's first time. Let me know how can I share. Let me
There's an icon with a screen in the middle
share
of
screen,
your.
right? Okay. Let me start sharing.
Yeah, of course.
Oh,
Take your time. Don't worry.
let me. It's asking me. Chrome bundle would like to record privacy. What's that? It's I'm able to share. How can I do that? I need to ask Google. Well,
There is a taskbar in the bottom of the screen in the browser
um,
with a camera and microphone.
my Apple says Google Chrome would like to record this computer screen.
Okay,
Google, how can I? Okay. Okay.
you
Let me
found it.
let me quick. I need to reopen. Is it okay?
I
Let me
cannot see it
reopen.
yet.
let me rejoin.
Okay, okay, no problem, no problem. Okay, George is going to rejoin. Just uh, a quick video, and he will be back, I'm sure. So, yeah, thank you, everyone. Perfect. George is able to share I'm sorry, I was muted. So, George is able to share his presentation. I'm going to bring George back on the stage as well as the screen. Hello, my friend, again. Uh, the stage is yours. You can actually take the driver's seat and make your session go.
Sure. Good morning, everyone. I'm George. I'm the lead architect, data and AI at Microsoft. I will introduce accelerating data workbench automation with agentic AI on Microsoft Fabric and AI Foundry. We're going to share some practice how to onboarding agentic AI to building out a real data workbench to helping us on business automation. Um, I'm not sure everyone noticed the AI Microsoft as CEO Schumann. He published an opinion in the interview. Uh, Most, if not all, white collar tasks will be automated by AI within 18 months. So I think this is really, I believe, is something is happening right now. So that's the reason we would like to share some our findings to building automation to helping the business grow into a intelligent way. I wish my agenda is covering the business background, problems, and motivation, why autonomous agentic systems are needed. Second, we will share a agentic systems architecture, how we're using hub-spoke agent design to address complex enterprise needs. We share something in the design, including context management and memory, how to build in skills and resource management, like how to build in workflows and using agentic AI, and how to integrate data services using MCP, and how to do tool governance. We also share how we onboarding agentic AI on the AI cloud through agentic ops, including tracing and scanning. We also share some our experience how to onboarding guardrails and safety for the agentic systems. At the end, we will give you a demo and show how we using agentic AI building out data workbench automation. Yeah, it's a large organization. We have a lot of needs for quality, new features, automation. So we are onboarding agent flow intelligence to helping to address these challenges. One is we would like to reduce time to value for the OS features onboarding. Right now we have a lot of features. Each time it takes time to building the feature, evaluate the feature, onboarding the feature, and get a feedback from the customers. So the overall time is very long. We want using agentic services to helping us going through feature either its design, build, deploy, and feedback. We have a full loop. Secondly, we would like to unlock cross-module knowledge sharing. As we're building a very complex product, there's so many features, maybe thousands or maybe 10,000 of features, and we would like to building a standard way can cross the team. We can share the domain knowledge. For example, in agent systems, we can building out standardized workflows, and we sharing in the intelligence using skills, so we can reduce a little bit dependent on specific domain experts. Number three, we want low authentication and access barriers. Uh, Here we can use the management identity and agent identity. This will helping us simplify the authentication and authorization. In a complex systems, there are many modules. Sometimes you will go into a complex situation, each of them using different security models. So we also care about the security. So we're building out a world without key. So keyless solutions using identities. Lastly, onboarding agent systems to a complex environment, especially in enterprise data systems. You were facing a situation. There are many new services. They also have services building for years. So, and maybe sometimes you also reach out like legacy systems as well. How to combine the new systems, the legacy systems, or other systems together. So, how to address these challenges. So we provide agent flow as these agentic solutions. It's a streaming complex AI workflows with agentic applications. They provide some nice features for us. One, we will bring a mature agent runtime architecture. We design this agent is scalable, reliable, and observable. So agent execution is critical since in sometimes agents where we're going to a situation is off board, is have a human analysis. So we need onboarding the agent behavior. We need some ways to track on how the agent execute. This time we bring the agent loop. Second, we would like to onboarding different features, like including domain-oriented agent skills, or we have different tools from different teams. So we will provide tool registration. We will have the centralized tooling and the skills layer that enables deep business domain knowledge. Third, we want the agent helping us to building out semantic routing and task distribution. Since in a enterprise environment, your tasks came from different angles, and then we also need to distribute different teams. So we need some kind of semantic routing for us. This is how we can distribute this ability from the agent to different teams and different isolation environment. This is how helping us scale the features. We also bring on the model context protocol. This will helping us onboarding the data services. MCP server is a product is a standard with how we align the different team and for the resource. More than that, we also need to figure out the best approach. You can bring your MCP service, but also you would like to protect your context. You don't want to get the tanks exposure or get polluted. So that's how we're building out the core flow. Yeah, I will show details in the design. We need also onboarding multi-turn reasoning and the decision engine. Most of the tasks when we're building out new features for our OS, there are many, reaching out to a situation need a multi-turn reasoning. It's not something we are asking questions, you get us feedback. Sometimes it's going through more than 10 steps or even more than 20 steps. It's even longer. So this multi-turn reasoning is critical, and we're building out this reasoning and decision engine. So this is also through our loop. And we also need to bring a human in the loop, since in some scenarios it's pretty complex. So it's some decisions can be made by the flow, but some of them still like corner cases. We need a human get involved. Lastly, we care about our security, not only for ourselves but also for our customer. So we bring responsible AI and agentic governance through this design. So we ensure a safe compliance and operational governance at scale. Okay. Um, we traditionally when we're building out this agent in the first iteration, we think about the traditional. We just we're using a traditional way. Like I say, user have a prompt, and then when this prompt going through a large language models, and then give a response. So this is originally we learned something from here. We found it's want to work well. So the design is first of all, it's something that's stateless. You send something, you get something. So you forgot next time what you sent. Secondly, you send something, you're waiting there. Since maybe you got something correct, maybe you didn't get anything. So we were blocking there. So and then you don't really know is right or not. So we changed the way when we're building the new iteration, and we going through some of the iteration. We found a way we will bring the streaming agent runtime. The runtime is a way we were using. We bring the from synchronous to asynchronous. So this new design, we will bring a planning, and so this is our agent. They understanding the users needs, and then going through our runtime. A runtime is asynchronous. Is a streaming way. User can going through each steps, and then you can think it's a loop. And then in cases they needed something. For example, if I asking to do something, they need to have some memory. So we can hook in the memory in a loop using hooks. And after that, the runtime will continue, and then if they needed your task is a complex task, maybe you need some tools. The tools could be short running tools, could be runtime job. So we will also hooking the tools using to our runtime. And that runtime also they need maybe they need a large language models. We're using an agency, and we can helping us going through the protection, and we have building out keyless solutions. We're using the identity as a solution. By bringing this new design, this new runtime design, we bring some new features. For example, so this is we can supporting non-running workflows. You can design systems maybe run from minutes to even hours. As far as you get something, we know you still need some more time to doing something, and we can return the partial results to the front, so the user can understand. Okay, this task is complex, so it's need more time. It was shortened, great. Yeah, you get something in a minute. That's cool. That's very fast. Secondly, we have the multi-step planning. So we have tool chaining. So we can even chain your tools together. You can do even very complex tasks. And we using hooks, and we have the memory, so they can persist the memory cross sessions. So that's give us ability. You won't just forget the things, and even in cases, even the things you failed, that's still okay. Since we have a checkpoint, and then they can have memory, and they can rerun it from the failure. And we support the partial output. So we'll talk about that one. And the reason we bring this design is, I think the majority is agents does not return single values. So in our first iteration, we give you something, you get something back. That's pretty much is ideal environment. But most of the time, enterprise environment is very complex. And we're talking about large language models. It's a large language model, it's a GPT models, right? It's built in a way we use a continuously send out token. And this token way sometimes, you need if you need more tasks, like say you need 2 cores, and then you need waiting, right? So from your starting, and then you're waiting, and then sometimes you will say get a partial result. Could be success, could be fail. Since this is the features from the large language models. Sometimes you have a humanities. Sometimes you get something right, and maybe you should design to fail for your systems to make the system very stable. So maybe suppose they get something wrong, and then we can take this as a feedback, and then how we will feed this feedback into your prompt. We reconstruct your prompt, and then we can continue, and then finally until you can continue this loop, and until finally you get your things success. So this is the behavior, how we can combine the context engineering and tool calling and then your feedback, and then even sometimes you need a human. Yeah. So this is going through a full loop. How we can building out an agent in a more stabilized way. This is just show you a real example here, and we building out an agent loop. And this is our current loop. And then user can continue to send the request came here. And going through this loop, we were going through make a decision. Do we need to have a plan? And do we have some steps? And then you have steps. We're going through these steps. And then from the steps, we provide a different kind of skills. So these skills could be a shell execute, could be CLI tool, and we also have a browser use execution, or we have tool use. For example, in this we're building our data bench. We will need the skills for TPM. TPM is a business features, yeah, for us. And then we also need in your skills, you maybe you need to call some machine learning serving APIs, and you can calling some other. We have some like Hermes data platform APIs. How you hooking your data, and from your data hooking, we have the real OS level data. And for these features, these features, we also need some data. So this data came from our Microsoft Fabric data platform. This data platform, we're building out a globally geo-distributed data lake house. We name it one lake. And then so from our TPM skills, is going to call it one lake. And from one lake, we get the typical business features. And also, you maybe have tools. Your tools is a cloud skills, for example. If that's the case, your cloud skills, you have some enterprise. Like I say, you will deploy on the Azure. Maybe you have a cloud skills for storage, maybe for compute, maybe for your infrastructure, or maybe you have some like emails or like ERP systems. So this is a way our agent loop can combine your skills from your browser use to your shell CLI, and then to your enterprise level features as well as your cloud features together. So that's how we can use a loop, and we in the enterprise environment can combine all of these features together. And then finally, the user side, we have the gateway or have a proxy, and then you can integrate to your systems, like say your teams, and you can submit your request from your teams, or from our data engineering, well, data workbench, or some other like applications, etc. Yeah. So these are overall examples. And in our design, we supporting different kind of engine. We can supporting like sometimes our engineers we need more control. You can use a Pi engine, or we using our own engine. So we have the Copilot SDK. So this is our own solutions. We can building out. This is very powerful tools. Also, we have an agency engine as well. So this is our new engine we are building out. So it's covering different kind of needs from your open source to our own source and to closed source. So this one is our own engine. So it's not open source, but it's a very nice engine. It's very powerful. And also more than that, we're building out our own plugin market. So we have an agency plugin market. We building our own skills. We're also working with the team internally across the organization, and each team they're going to building out their own plugins. So these plugins means their own skills for different domains. We mentioned we have so many domains, from ERP to cloud to infra to different features, etc. To data engineering, data scientists. So we're building a huge internal market. And in our runtime, we need specific skills. We can search, we can find the skills in our plugin market and install in our agent. Lastly, in cases everything is working fine, and we will also have a heartbeat. So we have cron job. So this cron job we can set up automation, make it running based on set up your cron like every hour or every day, depends on the business needs. So this is our example. So while the runtime is a hard part, what we learned in a couple of iterations to building out agent flow and with applications building for the data bench, we found it in the beginning we said, okay, we're gonna get some prompts, we got some agents, we got loops. So this one we just say is we pretty much lower the engineering weight and is easily replicated. As we feel this is pretty much very easy to do, but we found it's hard to control. Since once something happens, it's not easy to get something back. So that's the humanity's behavior from the agent. And also sometimes it's really dependent on the agent behavior. So sometimes it's make it a little bit challenging, make it not predictable. So we switched here. That's the reason we enhanced our engineering part. So we're using a lot of our resources to building out this runtime. So we can using more high engineering weight, and then we can build out the critical infrastructure to ensure the predictable behavior from the agent. So that's our agent loop we're building. So for example, we we ensure the execution is pretty safe. And that's the reason we're building out asynchronized and with the streaming agent flow, so we can handle different scenarios. Like I say, you can set up a retry. You can hook in your feedback. The feedback could be from a human or the feedback from the running exceptions itself. Secondly, we were using deterministic tools, and we were permission enforcement. For example, we're using the agency, we're using identity that enforce the permissions. For your system permissions critical in the enterprise environment. If you have one NIC, you have the distributed enterprise environment, you have different API or endpoint, have a serving. So we were going through different kind of authentication. So that's we bring the agent identity as well. So we will have the data plane agent. What's the permission will authenticate for the agent? He can run, he can touch, he can have access. Maybe he only have a read, don't have a write, for example. And for the management plane, we're still using management identity. So this from human level, we have the full control. Lastly, we're using the asynchronized. We're using asynchronized orchestration, so that we can supporting our partially streaming. Reply. For the memory, we also bring the memory design. We're using the markdown files. We have short memory, we have long memory, and we have a session level memory. So this is we check, we save our memory for each run, and then and then in future, if something we need to retry, we can reload. If something happens, we can do the checkpoint. So usually for the long memory, we slice the memory into chunks and save to using embeddings with supporting tool. This is also working with the learn something from industry as well. The embedded ones we can supporting vector the database. We're also supporting like a key-based search, so like a regular expression. Yeah. So last we can combine both semantic match and also the key-based, so make it more accurate. And for the for the search query vector search, this is used to helping us going through semantic matching and finding all of the meaningful like top matches. And we're using keyword of using BM25, and so we can have all the daily logs. We save to the files, so easy search. More than that, we're also building out a search engine and using a large searchable like a retrieval. We're building out a huge retrieval search engine to materialize this performance. For the search and how we can hook into our engine. So the engine we're going through a couple of like a engine loop. So loop will be different hooks. These hooks including before the agent start, and we also have the agent task execution phase. We also have the agent finished end hook. So and finally we do a checkpoint. We can save our checkpoint to our external. So this is the one for our bring. When something happens, we can bring the back. So the overall agent loop life cycle, user will send out request, and then we were building the context. This context including system level prompt. We have the session level prompt. Yeah, we just said session level, and this is a system level could be non is a global, and a session is each time you start a new session. And skills level, we have different skills, and we have the skills market as well. So it's related to that session, typically how many skills we needed. And then we go into model inference. So this is where this is where hooking into our backend GPT models. We're supporting different kind of models. We're also supporting like cloud models and OpenAI GPT models. Yeah. Then this model will helping us generate output. Yeah, output. And then they also providing us a plan and evaluate and a decision what kind of tool use. And then once they decide to use, we were definitely here is a place we can injection. Yeah. And after that, we can execute our tools. This tool execution could be a long-term tool, long-term running, could be short-term running. And then executing tools, we can using tool called hooks. We can helping us get a streaming result. This will helping us make a more align with our end user, so we can make an incrementally feedback for our users. Where status and we have a progress and what's the progress, and if we face something, and we can make more hooking into our UI. And lastly, everything working good, and then we have the replies phases. We will have a final response. So we combine everything. Yeah, not partially, we get a full reply. So this time we're going through these loops, and we have hooking into all of the information from different phases, and then finally give a return to the user. For the skills, we go into two phases. In the beginning, we build our own GitHub Copilot skills. It's using our own proprietary format. But lately, we also building out a relationship with Anthropic. So they building out a skills as a standard ways. So we adopted this way as our as a supported at standard as well. So usually skills is vision as the playbooks for the procedures. We building out like I say, you have root and have skills folder, and these have different kind of skills. Let's say you are doing building for data workbench, we have data analytics skills, and you will have skills. So the capitalized and .md files. So this is the root files. And these root files, you will have the like for example, you have the metadata. What's your name? Like say I have been the data analytics workflow. And what's this skills for? So we have a description. This is for cleaning or analysis what kind of data set, for example. And also, yeah, you have the location. And we have different kind of instructions. How you do analytics. Step 1, doing something. Step 2, doing something. Step 3, doing something. So this is giving you some typical guidance. From skills, we also have some resources like scripts. We also have scripts, etc. So we just using the standard way to management our skills. And then after the skills, we combine skills with maybe you also have MCP. In cases we have tools you need according to MCP. We combine skills, MCP, and also we have some introduction together. We make it a plugin. And when it's a plugin, we publish our plugin into a plugin market, so we can share these features. Once we finish these share features, some other teams they can download the plugins. So we mentioned it. Yeah. And this is a share example how this is we're working across different teams, and working different teams. Like I said, we have from right side, you will see we have different teams. They're working on different data solutions. For example, our OS data team, they're building on the Hemis data platform, and we have the different providers. Like I said, they have the data lake house, they have a temporary provider server, so like different. This is for OS. And then we also have some other service. This is for long-time job. This long-time job could be very long time, more than 30 minutes, maybe could be, yeah. And then we also have other services that we, like I say, the case we're going to show here, we're going to build a TPM. This is a security features. So we are building our server. This server we can use in our integration. We are using Microsoft Fabric. So Fabric open a API for us. It's graphic API. And also they also have new features. They have a JDBC JDBC API. So right now we're testing both of them. So this is our one lake. Yeah, one lake. We have Fabric database. We have Crucial database for this. Crucial database is for the time series database. One lake majority is for data engineering part. Yeah. Definitely, we also have some other REST services. So once we prepare this MCP server, and then we have the MCP client. So this client can communicate with our server. This is a place we can ensure who can access what. So for example, if your agent came in using skills, your agent have the identity. We're going to use identity to differentiate. Do you have access for each of the services? So this is we can build out keyless solutions for the authentication and the authorization. And then definitely for the skills, we will have the market, and we in the runtime we download. We have a skills artifactory. So this is a cloud store, so we can management our skills. And in cases we need to update, we have different versions as well. And then from the agent side, the agents will call our skills. The agent could be a single agent, could be agent flow, so could be multiple agent, or could be also have sub agent. So this agent is runtime. In the runtime, they need to load it. They need loading our like a memory. So we also have the memory management. Memory management on the cloud, so you can load in the memory. And also the agent need talking to the backend language models. And then we're using agent authentication. So this is how we can handle the identity-based, the low-key-based, identity-based. So we are calling backend large language models, cloud models, GPT models, etc. So we support a couple of ways. Also, you can bring your own like open source models. So we're supporting that. And then from the UI-wise, for here, we just show one example here. We're using a data bench. So we're building out our VS Code extension. So this is the one for data engineer or data scientist. You can you're using VS Code as a tool, and then we can build the extension, and then you can you can submit your request through our gateway. So this gateway where we're going through the agent, and then the whole system is working together. Yeah, this show you an example here. How we can from our MCP tools. So this show you how can data catalog skills and then with one lake integration. So we're building out our data skills here, and underneath we're building out a one lake. So we have MCP tools. Once we publish MCP tools, like say get a catalog, you can input your ID, and you need a different kind of like a schema support, or you need a summary, or you need doing something decision engine, or you need doing searching, etc. So you have the MCP tools, and then we're building out MCP server. And MCP server supporting different kind of protocols, could be streaming, could be HTTP, or could be SSE, etc. And then we building out a client. Our client using this connection, and they can invoke. So they can invoke our MCP server. And in our skills, we have the handler. So here we can supporting what kind of routing we needed, what's the parameter we needed from our skills layer. So skills layer is a place we define the schema. The schema, like I say, we have 4 operations, right? You have a search, you have a summary, you have to catalog, and you can list, etc. So we have the this is the place we define what the features we have. This is 1, 2. What's the function call or the properties for each of your functions? So we define our skills, and then once we definitely we also get the permissions in the settings. What kind of permissions you have? And then from the code agent, we can call these skills. So you will see we have we building out the 4 layers. For the one lake layer, this is our enterprise data layer, and then we have the business operational operation, and also have the domain expert skills. So this skills is very scalable. You can build out different skills for different features. So you can scale here, and and then this framework can build out. You can run many cases. And then from the one lake, you can onboard in different data lake house. You can build one lake house for your TPM features. You can build another data lake house for your automation needs, or from other ERP system, etc. So for each layer, it's easy to scale and can match different needs. And we also, in a very complex enterprise environment, we notice each team, they have different needs, right? Some of the team are working on one lake, some of the team are working on other like a runtime job, and some of the team running on the like a governance, maybe some of the team running on the decision engine, and they have some other layers, etc. So and we noticed that since for a large organization, they have needs for different, even for different languages. Like some want to use C Sharp, some are using Python, Java, or maybe TypeScript, or maybe Golang, etc. So we want to combine them together to building agent systems. That's the reason I think the benefit that we gain here, we can isolate the features using MCP servers. So underneath you can use your choice, and you can feel what's the convenience way for your features. You can use in different languages. Yeah. And we're using streamable as far as we speak the MCP MCP protocol. So we can use a streamable HTTP, and then we have the MCP client, so they can communicate, they can call your tools. And another thing is we have the agent loop. Since with the agent loop helping us going through different loops with different hooks, the hooks hook your memory, and then if your job could be very long, you like say machine learning inference, etc. It doesn't matter how long you get a response, since we are building a asynchronous way, so we can waiting until you get a response. And if you have some response, we can partially reply to the gateway, and finally gateway we go to our client side. So agent flow can go through this WebSocket and go to agent flow. Yeah. And definitely, agent flow could be just a VS Code or extension like a data bench. So definitely you can also supporting other clients. Like I say, you have a Max app or Teams app, for example. Yeah. So this is how we can combine enterprise needs and with our agent loop and then with our client and together. So we see this MCP as an integration protocol. And another thing is all of these services we design a way we're running on our Kubernetes environment. So it's a container, it's a Docker image. So it's easy to scale, and you can run it as a cloud native way or agent native way. This give you examples. We have the agent flow integrated with different MCP servers. So from our agent, our code agent, this code agent can hook into different. We're building on many MCP servers. We're working with different internal teams. Each team providing their own MCP servers. And then as far as we're hooking them with our skills, so our agents can easily integrate with different teams. So this is how we can scale the features across the organization. This gives you another example, shows how to building a flow. Like I say, from a flow, we need to run doing some data related research, right? We need to, like I say, we really search some data from the internet. We need to have the search skills. Search skills according to the search tool, and then we need to make an aggregation for the data. We duplicate the data, and then we will save this result to a spreadsheet, and then we will. We need to like do more process for the data. We do summarization. We need to going through some like a time window, right? And then we once we have the summarization, we need to also building a template. We need to render as a data, and then we generate a report, and then finally we need to save it to somewhere, and then we also need to do using specific format. And finally, we need to call enterprise email systems to send out the notification. So you see a typical flow could be from a search, research to clean, to aggregate, to reformatting, to generate a report, and then you save to your cloud environment, and then finally you send a notification. So this very non processing, like maybe 1 or 10 steps, 1 or 10 like a couple of steps. And then since our agent loop, we can support it like say, okay, I will send out this information, and then you do research, and then they get the information, and so this information, and then finally they can clean this information and do aggregation, and then finally they also show what are the progress. Do they save to a cloud storage and give us the to verify, and then finally they send out a notification as an email. And you will see you can open the link, and then finally you can open it. You will see, okay, let get something done correctly. So this will show another example. We have so many steps. We need to combine them together and ensure each of the steps is going through, make it predictable, and make it working on our track. And for the MCP server, for data bench, we have different servers. We have the OneLake server, we have the job server, we have the mail server, we have the warehouse, etc. And we going through a couple of iterations. So the thing here is we're building out a unified data lake house. So unified data lake house, you can combine a couple of teams the data together. Could it be a traditional tiered data, or could it be other data, or could it be some other like a data warehouse, etc. So we're building a unified. Once we're building unified ones, we're using a unified API. So that's we're building a GraphQL API. So we can easily make this API understandable, and then we have a GraphQL MCP server, and then MCP server make this expose the features, and then this MCP server can be understandable by the agent. And also we have other servers, so other teams. So you can use it building MCP server. So as far as you can building out a unified data server, or you can have different MCP servers. So both sides we can understandable by the agent. So this is how we can onboarding with different teams. Another way, another time, so we can make it more scalable. If other teams have some database, like easily you build a mirror. So you can mirror your database, and then in cases since we have one lake, you have very great features. You don't need to copy your data. You just build a bridge. So we already have the bridge. You can just bridge your data. So we can understandable what's your enterprise warehouse. So you don't need to really do moving anymore. That can easily hook into your current data warehouse systems. Yeah, very easy. So using these mirror features. Yeah. And definitely, if you already building out your MCP server, so we support it by default. So it's really easy hooking. Yeah. Other things we noticed for the experimental phase, some engineers maybe they already building something using like a Blob, using cloud storage. So you can also load your cloud storage like a Blob into your OneLake. So it was supporting the feature. So yeah. And this shows you how we do operation side. So we building agent ops infra on our Kubernetes environment. This including you say we're using container, we're using AKS, and we have corporate services. We have the our Fabric. Fabric is Microsoft data intelligence platform building for the agent world, for the general agentic AI world. And then we also have a catalog. So this is if you're working with a large organization, you need to understand where you are. You have a data map and you have a data catalog, so we can share across your systems. Yeah. So and for the user side, user came in and here we go to ingress. Yeah, this is the AKS ingress, and then we have the user interface. We have the workbench, and then user interface. And also they have some plugins. You can support different features from the user interface. And also from here we have the different MCP servers, including our decision engine, including our job server, our other mail server, etc. For we care about the security and author, so that's the reason we bring the identity support. So all the services you will see under the same VNets. So we make the highest network isolation. Secondly, even under the same VNet, we also bringing out a identity. So we isolated the identity for different teams. So like I say, some teams they care about their data, so they have their own identity. So that's how you handle the access control. And we have different teams that manage my own identities. And we also have the agent identity. So we grant the agent to combine with this identity together to make a combined authorization. And once everything is good, and in cases they need the feedback. Some feedback is from the loop itself, the decision engine loop itself. Some in cases, like I said, colon case, they need the loop, the feedback from the human. So we will send out the notice. We have the server notice server, and then the human the job will continue there, and they're waiting for the loop, and the message server was sent out, and they're asking the human to click a approval or yes or no, and after that the server will send it back, so the loop can continue. So this is how we can bring the support from a human in the loop. We have working with our agent loop together. So that's how we're supporting both the agent-based loop and also the human in the loop. Lastly, definitely we from a different server we have our own like a data lake house, data warehouse, and a database, etc. So this is part. Yeah. For the container environment, that's something we know. We our agent is a stateful container. Some of the decisions container like Docker image is a stateless. But for our agent is we mentioned that we need some memory, for example. So we save our memory into in the cloud storage. So that's the reason we create a PVC and then we create a claim so that we align this claim into our container. So that's we can do a security and a protection. And we also set up in case they need a config map to help us configure this claim and for the features. And we can build in isolation. Yeah. So this is a lot visible for other containers so that we can protect. And we also support namespace for our for the isolation. So namespace can helping us to differentiate. If we have different servers, we can isolate them. For the visibilities, we using Microsoft distributed application runtime. So it's a diaper. So we align this diaper and as a sidecar for our container. So each container we align a diaper. And this diaper and AKS we have a diaper server. So this diaper will broadcast and send this information into our like telemetry connector. Our telemetry connector is helping us to building the monitoring hooking into our agent the monitoring tools. This will give us a service level traceability. Traceability. So this is we find this is pretty useful since as we working in a multi-agent environment and containers, we need understanding what's the status, what's the health, and if something happens, like I say, we send, did they send us correctly? If you like to reply, what's the reply? So and if these services, agent services, they have communicated, call another MSAP server, for example, and we also have the information for the MSAP server, what status. So we can go in through each of them and trace the whole telemetry. Yeah. So this will give a full visibility for the cloud native services in like a multi-service way. I share a little bit more since we're talking about agent flow, and we're talking about agent flow in different cases. One, we can use agency as our engine. Agency is a major engine we are building now. I think it's pretty much we're hooking in the overall environment, including the different layers. For example, we have the underneath is our large language models, GPT models. And then from the engine side, we support a dual engine. One is GitHub Copilot SDK. One is cloud. One is cloud. So for second, we have the tools layer. Then here we have different agent. So we can build in our the agency itself have the main agent. We also have our own customized agent. For example, we are building our own agent for agent loop. Yeah, and on top of the agent, we have the plugins market. Plugins market is a place we can customize the features for agent behavior. So we have the the plugin market. So once we customize the building, we can publish to the market, and then in the runtime, the agent can download this agent skills. So here we can build your own agent. You can use in what existing agent. You build your own agent. We using the Copilot SDK, so we can build our agent, and then we loading our own skills. If you're using agency, you can use in this agent. Since we are using the same plugin market, we're using the same design. So you just download and install this agent, these skills. Is seamless the transfer from your agent to the agency agent. So there's nothing need to change. And also another way is we have the data workbench. So the top layer is glue. You can build in your own tooling, right? For here we build our own data bench. A data bench can use in a gateway, and this gateway can go in through our agent flow and going through our agent loop and going here. Or our data bench can also go into proxy. This proxy can proxy to the agency and the agency agents, and this agents and building on our own and Copilot SDK and for the GPT. And for the large language model wise, we both sides we're just using the same agency authentication. So we don't really care about the key based access. We're using identity based access, and that's how we can build as one platform. And even it's working as one platform, but also we have our own ability, and you can build your own skills, you can build your own agent. So that's how we can build a coexisting environment. And underneath, if we have our own MCPs, you can use in your data. So that's how we bring our OS data. So for different features. Okay, I'm going to give you a example here, and we're going to run the. I'm going to let me run. We will provide a end-to-end secure agentic data engineering as examples. For these examples, we will show how the agent flow can benefit from agency to provide business support for TPM data diagnostic. For example, attestation, health check, firmware changes, and verify decode of manufacturer IDs. Let's take a look what is here. So we're building out a copilot inside the VS Code, and we can ask him, say, list predefined skills. And then we can ask this agent. We have building out a couple of skills, like TPM skills. These TPM skills underneath is integrated with TPM MCP server. So you will see this all of the skills are already built out for a data engineering work. So you will see, TPM skills is already loaded. And now say show tools from TPM skill. We can list the tools from TPM skills. And then since the TPM, we have prepared a couple of tool sets, like around 5 tool sets, and we will share what tool sets they can provide for us. And you will see here, instead I have TPM hello, it's going to provide a report for success rate of the device and top 5 areas and top 5 failing OEM models for the past 7 days. And in the search, we have so many tools here. Let's say I want to run these skills, and this is a predefined skills. Let's say TPM load. So we're going to the agent. We're going to call this predefined TPM skills, and then it's going through our MCP. It takes 2 minutes. Let's go back and we'll revisit this one. So from the user side, we submit our request, and then this request goes through a proxy, and the proxy is calling our backend agency copilot is an agent. So this agent is loaded our predefined TPM skills. And these skills, we have a couple of tools we need to show you. And then underneath these tools, we already configured a security guard. So we're using a identity. Like I said, we're doing a handler. The handler is handholder. If I run from my machine, it's going to read my AZ login credentials. So my own credentials using my personal identity. And then this identity says before I run this case, it's already going to approve to access the TPM MCP server. So this new server and then is going to call our TPM data on our one lake. So one lake is set up from the Fabric workspace. Now let's see what is going on here. Can you see? It's still working. Still, let's continue. And then how this is kind of structured. You will see here. We have the agent loop, and this is called agency. Agent have 2 components. One is copilot, one is cloud. So right here we're just using a copilot, and then this copilot is calling the skills going through the one. And then from UI side, I created a workbench. As I showed you, this workbench is working as an extension. It's installed in the VS Code as an extension. Yeah. So
In order to make the extension working with backend agency service, I had to build out a proxy. Since in my design, we have two ways. One, using my own Pi agent, so we can use the gateway. It's very flexible. But since we want to benefit the building out into agency ecosystems, but this is not open source. So we had to using a couple of CLI, and so we do a proxy to the agency. So this is a closed source of things. We don't know how it's working internally, and we had to using like the rack, and this rack can working with extension. Let's see again. Is good anything? Yeah, good. You see. So now TPM Hello you see report was generated successfully for the last 7 days. So this is today's date, right? Yeah, from today's date. You will see they have the query and the success rate is like a 99%. Yeah, yeah. The failure rate is 0.5. Yeah, around that. Also, you get more details here on the area code. You will what's the top area code like a NTE, PM, etc. So you will show all the details. This is really help us for identify device that TPM is used. And it also shows the top 5 models with the highest failure rate, so like OEM. So you will see this is a couple of one OEM. And sometimes you don't know what that means. You can use in like decoder features. Let's say TPM decoder like that. Let's do the TPM decoder. Maybe this one. Let's see. These top 5 models show 100% failure rate.
George, I'm sorry to interrupt. Is there still time going on? Are you summarizing?
Yes. So I play a video. Did you see the video?
Yeah, of course we can see the video. I was wondering whether it's going to take more than 1 or 2 minutes. Do you have an estimate?
Yeah, I think pretty after this we're done. Yeah, so pretty much last sentence is yeah, this is QA and thanks for the team. So this project was is a teamwork. So like business support team, Anile and Jason, Yixin and Joyce, and the content review Alex and Chad, and the leadership sponsor Renzo. Yeah, that's all.
Okay. I'm sorry to intervene, but yeah, this is a shared space with other speakers as well. But nevertheless, we are very thankful for this workshop. It was an amazing, a huge workshop, just like our commenter here says. Do you have the repo anywhere for someone to replicate or at least, have a look there? If you can share it with me, I will also share it with the community. You can do it
Sure.
offline, no problem. You can do it offline, don't worry. You can send me an email or contact me through LinkedIn, and I will share it with the community. George, that was an amazing presentation, very technical, very deep, and very interesting. I have to rewatch it, of course, to understand specific parts of it. But kudos, my friend. Kudos. That was an excellent job. Thank you for being with us. Thank you for being our speaker for the first time. I hope we will have you in the future and in future conferences, whether are live or in person. Uh, have a great one, my friend. Thank you so much for being with us.
Thank you so much. Yeah, thank you for the audience as well. Yeah, thank you.
Great.
Yeah.
Wow. That was something, right? We started the day very powerful with George's workshop. And he showed us how we can really integrate a lot of moving parts here and there. And that was a very interesting presentation, I have to say that. So we have Matteo Emily coming up. Allow me to play a quick video and we will be right back with you. Thank you. Yeah, I was talking and I was muted. So again, let's thank George for this amazing presentation. Quite technical, very deep, and the integration layer was, to the sky. I would really like to see the repo of George. So I wish that George will share it and they will not forget it, so I can share it with the community. Already a commenter that is watching live, ask for it. Again, if you're watching live, thank you for being connected. Of course, the videos are recorded, and I know that our community will honor us. I can see the previous days are already reaching 500 and 600 views in very short time. So I'm really thankful. I'm also thankful for being members of our community. And without the members, of course, we cannot move on. Another ingredient of this recipe is our beloved speakers. So allow me to introduce Matteo Emgay and bring him on stage for making us the honor to be our speaker. Hello, Matteo. Hello. How are you? We cannot hear you yet. We cannot hear you. Let me play a video so you can find your. No, we cannot hear you. Cannot hear you. No, no, we cannot hear you.
How about now?
Talk again, please. Speak again. I think I can hear you now. No, I lost you. Can you talk again? Can you make one more try? No, no, no. Can you talk again right now? No, 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 no. You can rejoin if you want to. I can play a video for the time being. No, no, I cannot hear you. No, no, no. Please rejoin. It's probably something that will be fixed. Okay, Matteo will reconnect, so that video will play. Thank you for being with us. Azure AI Connect Day 5. Matteo will be right back with us. Thank you, everyone. So
Can you hear me
Matteo
now?
is with us. Hello, yes, we can hear you,
I
my
still
friend.
can't hear you. I was hearing music before, but I can't hear your voice, Konstantinos.
You not hear me right now?
If you can hear me, I'll happily go ahead.
I can.
I'll kick
I
off.
can.
Okay?
Yes,
Good.
I
All right.
can.
So, hello, everyone, and welcome to this session. Couple of rules for engagement. Any comment, any question, any idea, anything at all, I am going to keep an eye on the chat during our our moments with demos. And let me just share my screen real quick. Give me a second. So, where is it? Where is it? Here. So let me bring it up on screen. All right. doesn't work.
So we lost Matteo for once more. Probably some technical issues. I'm sorry for that, everyone. I know that you are excited to watch Mateo's session, just like me. Let me verify that I can. Yeah, I am live and I am audible. Here is Mateo. Let me bring him again.
Still
Hi,
can't hear
Mateo.
you, but I'm going to share my screen. If you can hear me,
Yeah.
sharing the screen. Sharing the window, sharing the screen. I have no idea what is going on today, but we will make it work. All right. So let me share the screen. Showing this screen here. Yep. You should be able to see slides, hopefully. Yes, you should be able to see the slides. So welcome everyone. And again, we will try to make up some time and try to recover. I am Matteo. I work at Avnet UK as the head of software engineering for what we call AMBG. Not really relevant. What really matters is that I'm a Microsoft MVP in DevOps. I talk about this all the time. It's something I do really out of passion. And today I just want to talk about how do we move from the hottest topic on the internet, which is vibe coding, down to agentic engineering. As I said earlier, any question, any doubt, anything that we want to discuss, please feel free to ask any questions and I will pick up as we go during the demos. Now, fair to say that software development is the perfect proving ground for Gen AI. There is no question about that. There are a few actual technology reasons. You are working, when you're working in programming with a programming language, a large language model, which as a reminder is not black magic, it will just generate the next most logical word after the one that's been written down. So it's really easy for an LLM to do that in programming space because programming languages are just a handful, hundreds, maybe thousands of words. It's not a lot, right? It's also very deterministic. Those are all things that Gen AI does very well. Let's say that, for example, if you start writing the word public, there's a very good chance that the next word is going to be class. So that's why Gen AI works really well for developers, and that's one of the reasons why we are moving forward in the industry. If you remember, when we started talking about Gen AI for developers, it was just auto-completion. It was just trying to help the developer in doing the basic things, the basic tasks. Now, if you think about it, we are already moving on to a second generation. The first generation was the GitHub Copilot of this world, Amazon Q, Windsurf. Those were the key ones. But in the span of a year or so, a little bit more than a year, we're now to a second generation. And this second generation covers Claude Code. It covers OpenAI Codex, Kiro, Copilot Coding Agents, Anti-Gravity, and there's going to be more, right? Because we are on the cusp, on the verge of a third generation where memory comes into play. As of right now, we moved from actual augmentation simply on the basic, on the stuff the developers do day to day at the basic level. We're now moving to agentic engineering, which is what we are talking about today. The next logical step is going to be memory, and that's going to change the game again. So that's something worth remembering when it comes to the generation and the tools that we use, because it's fair to say that generally augmented developers will need the right developer experience. And the right developer experience is not something that you build with months and months of work. It's not something that you build with a very long planning session and you try to stabilize things and you try to make sure that things don't change. That doesn't happen in the Gen AI world, right? So as a reminder, we talked about how we start. This was developer experience at the very beginning. Like you can see from the model that's there, Claude Sonnet 4. So it's a fair few months old, if not over a year. And this was very conversational. That was the first jump from auto-completion to actual international language interaction. And it could be something as simple as this. Refactor this piece of code, needs to be more readable, you get something out of it. Or it could be more on from a blank slate, from a starting point. I want to do something, it needs to adhere to certain standards, certain rules. And good developer experience here means I'm not going to give you the right answer right away, because your question is way too broad and your question could be a problem for the company. So in this case, matching public code was prohibited. Hence, we got this error and we got this message here. Obviously, if you continue and you insist and you persist on this, you're going to get something out of it, right? But that's a taste of what good developer experience is for generally augmented engineers. Now, vibe coding, we are hearing about it all the time. I talk about it all the time with my clients and my colleagues. The gateway to doing vibe coding right is literally prototyping, okay? Because we're now at a point where we can have something running in real time, in a real tangible application, directly from a couple of prompts. And I'll give you an example, all right? I will give you an example of this. When I'm just checking if there is any question or any at all. Okay, so fine, it works all right. So check the questions. So if you go here, and this is a simple, simple CLI. Ignore what's behind, right? But actually, let me just reduce it, just so it takes away the confusion. Now over here, I am in a folder called developer. Nothing, nothing here that's special. But I am a American football enthusiast as much as my wife is, and so many of our friends. And we always watch the Super Bowl together. It's the biggest game of the year. And this year, I thought, let's try something different. We're all talking about AI and stuff. Let's try to vibe code something on the fly, right? And I tried to vibe code a Super Bowl bingo, a web application. I could deploy in Azure. Everyone can play with it. And all it took me was an hour. Why is that? Because we're using tools nowadays, like the Copilot CLI, which, again, it's a bit of a spoiler for what comes next, but it gives you an idea of what you can actually do. Copilot CLI is a super, super powerful tool that allows you to vibe code really, really quickly. And in this case, what I will do is to say, okay, you know what? I want to build something, but before building, I want to get to a point where I am planning what's going to happen, all right? So I want to have an idea around what I am trying to vibe code rather than just jotting down something pen on paper and try to make it happen. So in this case here, I will say I want to build a simple tic-tac-toe that runs locally in my browser. Let's say something simple, nothing special, nothing, nothing that requires too much effort. Now you can see the chain of thought here. Before we get to the question, you can see the chain of thought. You can see that the CLI, I'll zoom a little bit, starts understanding the question because this goes to the Claude Summon model, and then it starts asking a few questions. So the agent, the model behind there, is asking me, how do you want to make it happen? You want two players locally, single player versus AI, both modes, or anything else? That's okay, fine. 2 players is fine, locally, no problem. Now over here, again, what technology stack you want to use? Those questions, they might seem, a little bit simplistic in a way, but you will see towards the end of the session where this is leading, okay? And for now, as I said, just the simplest possible thing, HTML, CSS, and JavaScript. I don't want dependencies. I don't want to do anything. I don't want to build, I don't want CI/CD, etc. To the point that I want a single index HTML file. I don't want anything else, right? I want everything into a very simple application because I'm testing an idea. This is literally just an idea. And now you see the chain of thought proceeds, and it starts building a plan. Now, this plan is nothing, okay? So this plan doesn't build any more than a set of tasks and a set of steps that something in the future could implement, okay? So in this case, you see that the summary is, I want to use this technology stack. I want to have this output over here, so a single file in this folder with 2 players. It's built on a 3x3 board with players indicators and so on and so forth. Now over here, I've got options. I can make some further changes. I can accept the plan and building with standard permissions, which again, it doesn't really help us in a way because I could do that, but I would need, if I never run this before, I will need to approve every single step. I will need to approve every single command. I could exit plan mode and build stuff myself, either with prompting or manually, or I can accept the plan and have it run in autopilot, which is what I'm going to do. And I'm going to run it with all permissions because, again, it's a very simple application. It only runs in my folder. So over here, now my model is going to build a project for me. It's going to build everything that I need, and you will be able to see how it does that. But it's all based on the plan that was generated before. So very important. We're not building something out of the simple idea, but we got a scoped down set of requirements that we need to satisfy. And the reality is that this is what he has just built. I would say seems to be working quite fine. This is vibe coding, right? Now, in the real world, okay, because that's what we are interested in the real world, vibe coding in an enterprise should not really happen this way. Or rather, it can happen, no problem with that. But the reality is it's less effective by doing it this way, simply because you will run into policies, you will run into governance, you will run into issues with toolings, permissions on your machines, and so on and so forth. So we get tools like GitHub Spark. GitHub Spark is a favorite of mine, all right? Because here you can ask your models anything, all right? And you can quickly prototype applications based on what you're asking the models to do. So for example, another passion of mine is video games. And I have a CRT TV just behind my back when I play with the game console of my, my child age, and I want to collect all the games that I had in my childhood. Brilliant. So rather than having a usual Excel file that every enthusiast uses, I decided, you know what, I'm going to build something with AI, so at least I can, put it into practice. And I started using Spark. Now, we're going to see the current state of it, but I want to show you, as soon as it loads, okay, there it is. I want to show you the original prompt that I used. In this case, my idea was very well structured, okay? So I want to build a site that tracks my video game collection, needs to be able to track entries for these consoles, needs to have, every entry needs to have the following properties, name, target price, etc. You need to take the logos from certain websites. You need to do certain things. You need to be able to delete the game from the collection. You need to be able to export a file for, like, it's a number of requirements here. Okay, it's a lot of information. Now, over time, I will start building stuff and I will start prompting, as you can see here. But this is what I'm going to get right away. If I'm prompting something, I'm going to get an immediate validation of my idea in an environment that is React. Okay, so we're not talking about anything particularly proprietary. The only real proprietary thing, if you like, is the database. The database is a key value storage system that GitHub Spark uses to validate your, behaviors and to make sure that if you need a database, you can test it that way. And at the end of the day, we will see what happens after. But at the end of the day, you can get something that works. It runs in a browser. And as you can see, you can go back and forth to various iterations and various prompts. You can change the code yourself, as I've done multiple times. And you can get you get transactions, essentially. Every time you build something, you iterate on something, it's versioned. All nice. I can publish it, and I can say, okay, you know what? I like what's coming up over here. Let's see how it runs in a test environment. My test environment runs on GitHub, and there it is. Right? This is a sample application running on the GitHub environment. Reality is, it's a fantastic way to prototype. Okay, and if there is anything in particular that one wants to try, this shortens the feedback loop extremely. But the reality is, yes, you can share it with your team, but realistically, this needs to become something else if it needs to become an enterprise application. And the enterprise application comes the moment you start treating things as they're supposed to be treated, as real code bases. So the first thing is that any GitHub Spark can actually be stored into a Git repository. And that's the starting point, right? As you can see, my game vault tracker is generated from a template, from a Spark template over here. Now, that is brilliant, okay? And that gives me the ability of versioning, and you can see everything in here. It has 50 commits, because that's what I've done. That's every time I iterate on something, then I get another commit. It's treated as actual application code. But the beautiful thing here is that in a real world environment, and follow me for a second because now the names could be confusing. MyVSTS here is my personal account. Okay, this is my personal GitHub account. It's nothing, it's like in a real organization. This will be my personal account doing something potentially connected to my organization, but that's mine. That's my experimentation. In the real world, the first thing that I did was cloning and forking my code onto an organizational repository. Now this, as you can see, it's forked from an individual one, but this is also Matteo Emili, which is my organization. So this represents what could be an organization, a real world team, a real world business unit, or anything else in between. It's simply the way I named my GitHub artifacts, but that's where we are. And here is where you start modifying your things. Because otherwise, if you start committing to the other repository over here, every time you change something, you will see here at the bottom, but this is manual edit over here. This is a mistake that I've made because I pushed by mistake a commit towards the personal repository rather than the corporate one, if you like. And that has caused problems because it has misaligned my code base. So in the real world, when we prototype and we do something, then we have to go by best practice, via an organizational repo. Now over here, this is where I'm starting. This is where I can actually work with my code from an enterprise perspective. This is like any other code base in my enterprise. But the first thing that I would do if I were working on this code for real would be something like this. As I said earlier, we have, we use the key value storage system that GitHub Spark provides. And I told my agents, and we're going slightly further away in the session, but I told my agent that this is an application that I prototyped with GitHub Spark, built the front end, I'm fine with it, but I need to remove the key value storage system and replace it with an Azure table storage I already created, because I want to make it real. I want to make it a real application. I want to make something that, something that can run in Azure. You can't deploy GitHub Spark's key value storage system. So I explained what I needed to do, and then I started an agent. This is an agent that's been doing it for me. This is an agent that ignored the 126 days. This is when it actually happened, but I reopened it a week ago, and so it got synchronized. Okay, it didn't take 126 days. But this is what my agent has been doing. And the agent does a number of things. First of all, it iterates, and it generates a lot of documentation, which is fantastic, because every developer, as we know, struggle with documentation. People tend to focus on code, and code might be excellent, very readable and so on. But it's always, it's always something that documentation that comes after as an afterthought. But also, most importantly, this was not done first time around, because after an experiment, I said, okay, look, games are not saved; they disappear. It's not working. And here, the agent continues to iterate multiple times, telling me what's been done, what's changed, and what's been documented. It tells me how to debug things. Sometimes it even builds custom tools for troubleshooting, for deploying, and so on. And it's fantastic, because I can talk with the agent, I can chat with the agent, and the agent will do it on my behalf in the background. I don't have to worry about doing things myself and having to feed and water my agent. The agent will just do stuff. In this case, it's going to be really quick because it's a simple thing, but it's a matter of a few minutes. But in big enterprise cases, it will take a few hours even. We can just run. There's not a problem. And as you can see, it doesn't work first time around. Like, this is the third attempt, and eventually, it's going to get it right, and it's going to be real. Okay, and then I did other things, as you can tell here on the right, including CI/CD, bicep template, and so on. Reality is that this is, this is running now. Okay, it's a real application, because if I actually, before we go there, realistically, I can go here and look at the actions, so you can see the reality of things. You can see that the last one, the last feature that I built is this one, PR13, and I can go and open it up. I can see what's inside. I can show you. I want to show you the main one before. This one. So over here, unless I've broken something, which again, it's always likely because I play with this all the time. There it is. And this is my actual collection, okay? But this is something that's been done with, I would say, an afternoon of work, or I got to a point where it's not working. But it's something that everyone can go from prototype down to actual application in a matter of minutes. And it's brilliant. Now, I don't see any questions, So I will continue, but if you have any question, as I said, in the chat, let's talk. All right. Now, the other thing, and we talked a little bit about it, but everything, and you saw, how about agents? You saw the agents, like agents will give you speed, agents will give you actions, they will give you the ability of doing something in minutes, all right? And it will give you control. So it will give, for example, do a pull request, please do the pull request. That's what it does. Those are the outputs. Those are the very, very fine, fine-tuned, finely reviewed results. And it's brilliant because we'll see that in a second. But CLIs are the control surface of vibe coding. All right. So you saw how the CLI works in practice. You saw how you use GitHub CLI to build an application. But realistically, and actually I'll go out of the slides because we're changing the way we're showing it. But when you run an agent and you go over here, right, and you're going to say, okay, fine, I want to run an agent. The agent is not necessarily via CLI itself. It will run in the cloud potentially. It will do things, but it could be exposed by CLI. So that's your control surface. Now, you can interact with an agent, and the agent could be something different. It could be pick up a new feature. In this case, it's very crude, sorry. And it can do something. Now, that's interesting. That gets really interesting because there's something new here. It happens as of a few months ago. The agent will run and will implement whatever is necessary, whatever is designed as part of the ask. The interesting thing is that my agent will do everything, will implement everything, will do all the things are needed in the session, okay? But it will also give me a visual check on whether the agent itself is implementing something correctly or not. Now, in this case, the evidence says, and bear in mind, this is just a screenshot, okay? So this is not, it's a PNG file. So this is nothing special that the agent is doing. It doesn't have access to an environment where I just built it locally. Now here, the interesting thing is that what I've done is getting something done. I didn't like the output. It's wrong based on the evidence. So, okay, fine. Copilot, please change the model that you're using, because here I was using OpenAI Codex, and change the model, and please implement it correctly, because both toggles only show the live theme. Can you implement dark mode for real? Lo and behold, it gives me the evidence after 6 more minutes that it's been done. All right. So I love it. Brilliant. Fine. Let's go to pull request. This actually lives in a pull request. The pull request can be reviewed by other agents. We're not getting there right now. But this runs the whole process as a pull request, which means that with a pull request, I'm also getting my CI/CD running, which I can see over here. Just comments on PR number 13, for example, right? Now that's the session where it's done stuff. That's the session where it has actually corrected things over there. And then over here, it is running my CI/CD again. It's running against a different environment, mind, because over here you see that there's nothing. Sorry, no, that's not the right one. So over here, you can see that there's no dark mode button, all right? And you will be able to see that if I build and deploy here, I go down to the bottom, it's a different URL. This is Victorious Sand something. This is the nice sand something. Here it's empty, because obviously I didn't seed the information in there, but I have working change of theme. I have a working dark mode. This was done in the grand total of 15 minutes, okay? Because if I go back to my agent, session, the PR number 13, 2 sessions, 2 premium requests, 8 minutes 41 for the first one, 6 minutes 18 for the second one. So it's literally 15 minutes. I got my feature implemented. This was running in the background. I didn't have to do anything, right? I didn't have to check anything, make any change. I just gave prompts based on the evidence. Imagine what this can do for a developer. And this is where you move away from, oh yeah, let me try something vibe coding. This is structured. And it becomes even more structured in an enterprise environment when you use Copilot instructions. Copilot instructions, and here is an example. They are very specific files to be used for agents where you can explain what the repository does, what's the content, how to build something, what's the validation that needs to be in there, endpoints, configuration, and what are the timings, so that the agent can notice whether, for example, there's something that's giving a timeout and is not working correctly. If, let's say, the build takes 10 minutes, then clearly not right, and there's a 5 minutes timeout. Those kind of things. All right. Now, we saw how to write code. We saw how to, how to build something from scratch initially and then make it real with the IDE. I'm going to go to the last one, the last point. Now we got the vibes. I think it's fair to say we got the vibes in place. Now we need to govern the vibes with reliability. And the way you do it is with something called spec-driven development. Now, spec-driven development is a tool to a degree, but in reality, it's a way of leveraging AI creativity so that you can break down big pieces of work into digestible chunks, all right? And this is how you get scale with your agents, because that's where you can actually go out and build big things. So let's have a look. Now, this is an application that I've been building for the past few weeks. It's called IAC Composer, okay? And I will show you how it's made. I'll go to the backend first, and this is .NET Run. Ignore the error messages, all right? And then I open another one, go to the front end, and this is VM. Now this is a real application running on my machine. What this thing does is collecting some of the Azure verified modules files and from a repository from Microsoft, allows you to have a simple composition experience, a simple marketplace experience where you can configure a few things for any given resource type and then export a zip file with all your definition in bicep. Very simple in a way. Imagine how long this would take to build from scratch as a developer. It's not going to take you hours. Okay. The way I've done this is by using spec-driven development. Spec-driven development, as I said, it starts with, it's essentially a set of scripts, as you can see here, with templates and a CLI, very simple. But what this does is picking up the high-level requirement and applying a very precise structure to break down the requirement into tasks that can be given to agents. So it uses something called a constitution, which is a set of principles and memory that it uses at all time. And it uses some templates, as you can see, which is going to give you a basic structure. Everything can be changed. Everything can be amended, right? So it's nothing, nothing set in stone, nothing proprietary. You can just do whatever. But what I've done over here, and I'll close all the files so you can see. I told my agent, I want to build a website in that way. And this is using a custom agent here, as you can see, right? So the first thing that I've done is to use the specify init and the specify command. Okay. So here I said, okay, fine. You know what? Specify this application. The application is a visual composition and infrastructure as code asset that comes from the Azure verified modules repository. I didn't really say much more, right? The UI will allow me to select workloads, specify configuration, and configure it together. Brilliant. The repo is here. It's running with Codex Max. That's all I have to worry about. From there, it starts doing its thing, and it builds a couple of files. It builds a spec, first of all, and it fills in the requirements file, right? Requirements, we don't really need it here because the requirement is one. But the first thing that it does is creating a branch for the spec, and the spec is here. Let me just bring it up. Let me bring it up here to move into new window. So this is the spec, the initial high-level spec. Okay, so this is going to be something that is going to drive the quality of the outputs of my agents. That's just the starting point, right? Okay. Then it's also going to create something called a plan, which is more interesting because a plan is based off a feature branch And my feature branch is obviously going to do, it's going to do certain things. It's filled, as you can see, by this command, and it uses this template. So this plan over here is going to be about my application in this stage with this requirement attached to it. Okay, and that's what it's going to do. As of right now, there's nothing technology. I haven't specified a stack. I haven't specified anything beyond what I want to do and what's my goal. Fine. From here, I'm going to say, okay, create a plan for this spec, build it with ASP.NET Minimal API for the backend. Don't care about the front end. It will be agent maintained, meaning that you need to prioritize agents. If you need a database, use stable storage, simplicity. And then it starts building things. It starts filling more information and asking me, do you need a constitution? Do you need, key gates and everything? I said, no, fine. I just need, use whatever is available as a template. I don't need to ingest the GitHub repos because it's asking me here, provide a GitHub token for higher rate catalog pools. You can fetch them as needed locally. Fine. Now from here, that's the interesting bit. It starts breaking things down. So my plan becomes a spec, or rather my spec becomes plan and then gets implemented. But here, I have user stories. Okay. So here, I went from the idea down to a number of user stories. Every user story with functional requirements, every user story is going to have success criteria, is going to have measurable outcomes, is going to have assumption, edge cases, the whole thing. Which is incredible to think about it, because this takes just minutes. And then the next step is, okay, break the plan into tasks. 29 tasks got generated in a matter of minutes, and the tasks are something like this. Just pick it up. Tasks are divided into phases. As you can tell, three tasks in phase 1, 7 tasks in phase 2, etc. And it goes on and on. It calls out dependencies. It calls out what can go in parallel. It calls out what's the implementation strategy, all by itself. I can check it. I can amend it. I can review it. And then I can say, okay, you know what, agent? Start implementing phase 1 to 3. That's all I've done. I told it to implement it, starts doing it. Some things don't work. I got an error, could not load catalog, make sure the backend is running, but the backend was running. Same error, twice, goes on, starts changing things in the API, starts changing the structure, the agent restarts, making sure that it's fresh. It tests things, it tells me that it's working. I said, no, it's not working. But I briefly saw the sample modules loaded. So once you restart, everything is gone. Brilliant. Fine, that got fixed. Now I get another error, give the error. And at the end of the day, once it was done and finished this, I get the application running, which is incredible to think, because this was an experiment of an hour on a Sunday afternoon. So it's something that agents will allow you to do in a very, very simple way and in a very powerful way. The last thing, because I noticed the time, the last thing is remember to choose the right model, because different models will have different capabilities, different impacts. Claude Opus is going to be slower, performance will be lower, but it will be a thinking model. Claude Sonnet, I particularly like because it's fantastic for implementations. Gemini 3.1 Pro, brilliant as well. It's a reasoning model like Opus, but very, very quick, different level of reasoning. But again, there's a model for every task. You should not just focus on a single model. And now, for any question, please, because I am done with slides, I'm done with demos. So any question at all, please ask away. And thank you very much for your time today.
Thank you so much, Matteo. That was an exceptional presentation. I would like to thank you for being
Keeping
here
an
with
eye
us.
on the chat over here to see whether there is any question that's coming up.
Please open the YouTube channel. Are you there? Can you hear us? Can you hear me?
All right.
Can you hear me? Can you hear me now?
Konstantinos, I still can't hear you, unfortunately.
Look at the message. Look at the message. The message.
Right, open the YouTube so you can hear me. Let's see.
Message. Look at the message. The
Yes.
message. Okay.
Open the YouTube so you can hear me.
So
All
we
right.
don't have
No,
a
I have a bit of
question
lag,
for now.
obviously, because I can hear the live stream. Brilliant. But again, any question? All right. No, I have a bit of lag, obviously, because I can hear the live stream. Brilliant. But again, any question? No, I have a bit of lag, I can hear the live stream. Brilliant. But again, any question? Right. I don't see any question coming up in the chat. Well, thank you
No
very much then.
questions.
And
I
have a
would
great
like to
weekend,
thank
everyone.
you.
All right.
Thank you.
Till
Bye
then.
bye. Bye bye. Right. You know, when you're live streaming, when you're live demoing, when you're doing anything live, the gods of demo, as they are called, they are going to intervene and they are always going to challenge your plans. But we made it. Matteo did an excellent presentation, quite technical, I would say, but very, very useful. So I recommend you, if you just joined or if you didn't have the opportunity to focus on the presentation, to return and see the recorded session. It's absolutely brilliant. From Matteo, thank you, Matteo, for presenting such a wonderful theme. Uh, a very a very hot topic. I don't like the word hot topic. A very current, let's say, technology that many people are interested in, and Azure and Microsoft have provided an excellent user interface for people to get onboarded into the agentic space, whether you are pro code or whether you are in the low code space. I don't see our next speaker. I'm a little bit worried on this, but we are used on difficulties on our channel and on our live stream. I'm going to have to play our video and grab some water probably or your favorite drink, and we will be right back. Our next speaker for tonight, which is the last day of Azure AI Connect 2026. I'm really thankful for everyone joining, for you guys, the community, the attendees, whether you are watching the live stream or the recording. I'm very thankful for supporting our community. Invite your friends, whether they are technology enthusiasts or experts, and observe our pages where there are also opportunities for anyone interested to be a speaker. I'm very open to for people, especially when they are new into the technology area, and of course the Microsoft and Azure ecosystem, to take the stage, um, make their first speech, use our channel and our communities, Global AI Athens and Azure Innovators Hub, to exercise their speakers' skills, to overcome any second thoughts whether they are meant to be public speakers. Everyone is meant to be a public speaker. Humans are brilliant in communication, and that's our strong sign. We just need to be able to construct our persona, let's say. You can see that I'm very straightforward. I'm being myself, nothing special. So whether you are interested to be a speaker, I can also help you, mentor you. Whatever it fits to you, I will be there to help you present to us your ideas, your thoughts, probably your demo, what you have built, what are you envisioning for the cloud technologies in our channels. So again, have a look in our pages, globalai.gr and cloudblogger.eu. You will find everything there. There is a form where you can submit your speech, or you can just contact me directly and we can take it from there. Our next session for today is with Abhit, self-service BI dashboard generator using AI. I don't know whether he will be able to present, but I will play our video and I will come back to you with updates on our next session for the last day. Azure AI Connect 2026, everyone. We are going strong. So okay, I'm sorry, something with the mic is deciding to go mute. So as I was saying, our speaker is nowhere to be found. I just hope that Abhijit is fine and there is no problem at all. You know, we're humans. Sometimes we cannot make our schedule go as planned. But I have found Javier Villegas. Javier is a very well-known senior professional in the space of data mostly, and we are very lucky to have him with us. Javier is going to present a session that is very interesting, and I'm going to explain exactly and describe the session. So the session is, of course, about SQL or SQL, as we call it here in Greece. So it's SQL, and we're going to see the latest innovations in Azure SQL and the brand new SQL on Fabric, with new possibilities for mirroring and intelligent analytics. We will also unpack what's coming in the next version of SQL Server, from performance enhancements to security features. And finally, we will discover how Copilot can help us to interact and manage data to enhance productivity for data professionals. So uh, that's what Javier does, right? He is the go-to person, the expert, the senior professional with a lot of experience on data and SQL servers, databases, Azure, and we're very lucky to have him. Again, as I was saying, we have welcomed Javier again in the past in other events of this channel and on our other channel, Azure Innovators Hub. So Javier is coming in a few. Embrace yourselves, take a comfortable seat, grab a drink or something, a tea or a smoothie or your favorite drink, and we will be right back with you with Javier Villegas and everything about the brand new SQL Server and, of course, Copilot, Azure SQL. Thank you, everyone. We will be right back. Okay, perfect. So as I said earlier, we're very lucky to have Javier Villegas with us, uh, an expert in the ecosystem of Azure SQL, data, Microsoft Fabric, everything around it. Uh, we have hosted Javier again in the past, and I'm very grateful that he was able to connect in such a short notice. His session was planned for later, but probably a misunderstanding because this specific event didn't send calendar invitations. Anyway, flexibility, as we say in our language. Let me bring Javier in the stage and welcome him. Hello, Javier. I'm so
Hi,
grateful that you're
Francisco. How are
here.
you? How are you doing?
I'm doing great, and I'm very happy to see you. You're doing great as
Likewise.
well. Great,
Likewise.
great.
Thank you for the invitation and well, happy to be here as usual.
Thank you for being here. We're very grateful to have you. Your expertise, is golden. So I'm going to let the person do the work. You're driving. I'm going to share your screen as well.
Very good. You see the screen, right? So let me move the
Yes.
second. All right, let me start over. Okay, here we go. Let's start with the presentation today. So the name of my presentation here is SQL Server Supercharge Azure Fabric and Copilot in Action. The idea is basically to come up with what SQL Server and all its components and flavors are today, right? I'm coming from many years using SQL, and nowadays SQL is an ecosystem, it's a platform, right? It's not what it used to be. So the idea is to go through what it has been the last few years. A little bit about myself. My name is Javier Villegas. I work at Mediterranean Shipping Company as IT director in the DBA and BI services area. I've been involved with SQL Server for over 30 years now, and I'm Microsoft MVP in the data platform award category, as well as a Microsoft certified trainer. Uh, I'm one of the local organizer of our local community, SQL Argentina, in where we have our user group and our monthly meeting. You have my contact information here, the email, X, LinkedIn, etc. And also you have the QR code in case you would like to engage and get in touch with me. If you have any question regarding to this presentation, feel free to reach out to me. So let's start. SQL Server used to be a monolithic platform running on an on-prem bare metal machines, Windows Server for many years. But that is all gone. Now it's way different than what it used to be, right? And the idea today is cover what Microsoft called the Microsoft SQL from ground to cloud to fabric, right? And recently, actually last November during the Microsoft Ignite conference, there were many new announcements related to this SQL ecosystem, right? So what is important here to understand is that doesn't matter where you run SQL or to which SQL you are connected to, that we're going to go deeper into this in a minute. There is a layer that is common for all of them. We have the SQL Server on-prem, right? The latest one, the latest and greatest is SQL Server 2025. We also have Azure SQL, in where we also have some different components within it. And also recently, Microsoft announced SQL database in Fabric, right? It doesn't matter where you deploy your user databases, right? The T-SQL language that we use to develop in SQL is exactly the same. So does not change at all. Same for the SQL engine, right? All the optimization, all the goodness of the SQL engine, the query execution, the plans, etc., are exactly the same. Of course, tooling, right? You can use Visual Studio Code, you can use Management Studio, and you can connect to any of these components. Also, Fabric. Microsoft Fabric is the new addition to the data platform family, which has already 2 years in the market and is this analytical platform in where you can do end-to-end project, data analytics project, right? With SQL, right, we can integrate very easily with Fabric, so we can also use the operational data that we have in SQL servers, in tables, columns, rows, and send it as quickly as possible into Fabric in order to do analytics. And of course, AI and Copilot, right? Microsoft is betting hard in AI. So in SQL Server, now we have AI that we're going to see in a minute. And of course, Copilot. We have in the tooling the possibility to start having this side chat with our database and ask many prompts that we will see also later on. If we expand to a further up level, we see that we can almost run SQL Server everywhere, right? SQL Server on-prem is still available. We can download the installer and install it into our bare metal server. The good news is that since SQL Server 2017, we also have the possibility to run SQL Server at the top of the major Linux distribution like Ubuntu, SUSE, and Red Hat. Additionally, we can run SQL Server at the top of a container in Docker or Kubernetes, right? So that is great. Not only Windows, but also Linux and containers. Additionally, we have Azure SQL, right, in where we have multiple components. We have SQL on virtual machines, right? We also have Azure SQL database and Azure SQL managed instance. We're going to go deeper into that in a minute. And as I said, Fabric SQL database, the latest addition to the family, right? Okay, so let's explore what SQL Server 25 is and what was presented recently in this area. SQL Server 2025 is this AI-ready enterprise database from ground to cloud. What does it mean, right? And let me tell you something. Every time that Microsoft presents a major SQL Server version, ourselves, the community, the data professional, keep wondering what are they going to be adding to SQL. SQL is a product that has more than 30 years in the market. So, tables, relationship, foreign keys, indexes, what else? And Microsoft keeps surprising us with all these additions, right? One of the most important additions in SQL Server 2025 is AI built-in, right? We will see that we have the possibility, right, of having a new vector data type natively in SQL Server, so we can connect to any large language model through a REST API connection, right? And get the vector, get the embeddings, and store it within the database in the native form. This is huge. Additionally, in the development area, Microsoft made a lot of investment in order to have modern data applications. And we will see all the features that has been introduced for developers in SQL Server 2025. And of course, as I briefly mentioned before, integration of your data with Microsoft Fabric in order to bring into the analytical platform all your operational data as quickly as possible, as near real time as possible. If we expand this view, we can also focus that in this build, Microsoft keeps doing security by default, right? Integration with Entra ID, Microsoft Defender, you name it, right? So SQL Server is secure by default, right? And of course, this is your mission critical engine to run your application. When you go to production, when you have to achieve high availability, disaster recovery, and performance, SQL Server is the way to go. code. And there are also additions in this sense. As I mentioned before, AI embedded into uh, the, the SQL Server. It's also optimized for the latest and greatest hardware, modern hardware, right? And of course, is assisted by Copilot, and we will see it later. If we focus for a minute in the build, in the features that are targeted to the developers, we will see a bunch of new additions. For example, we will see that in this slide that the dot square that we have on the screen is SQL Server. The first addition is this GraphQL, Data API Builder. This is not part of SQL. This is an external application which allows you to connect to SQL, right? And basically, what allows you to do is to create REST API calls with GraphQL, so other applications can connect to that endpoint and interact and integrate with your SQL Server, right? So this is really, really good. Additionally, for the very first time, we have JSON data type as a native data type, right? We know that Microsoft has been giving us JSON since previous version, but this time there is a native data type. And additionally, there is an index capability for JSON data type. And of course, there are more and more objects and functions in order to handle your JSON object using transaction. Additionally, we have improvement to SQL to T-SQL, with regular expression. Right? There are multiple improvements in the sense of regular expression. Additionally, we also have a new feature called Change Event Streaming. What is Change Event Streaming? Well, probably you are familiar with Change Data Capture. Change Data Capture allow you to keep track of all the changes that you do in SQL for your data. Let's say you have a table and you do insert, update, delete, right? With Change Data Capture, you send all these changes to a different schema, a different table, and then you may have another application pulling from those tables. So you keep track of all the changes. With Change Event Streaming, I would say that probably is the evolution of CDC, Change Data Capture, right? And you can stream those changes directly to an Azure Service Bus as a JSON format, as an event, right? So directly from SQL, you don't have to specify, or you don't have to have any man in the middle to convert those changes and populate the Azure Server Event Hub. Directly from SQL, you push the event, right? And then you can have multiple consumers reaching Azure Event Hub and getting those changes. This is basically targeted to modern application development. One more thing is REST API. So what is this? Remember at the beginning I mentioned Data API Builder, that we can integrate our SQL Server so other systems can integrate with it using GraphQL. With this REST API calls within SQL Server, what we can do now is reach out to any REST endpoint and get, all the events. For example, you have a REST API endpoint which is returning exchange rate, right? How we used to do before. Maybe you have to create a link server call and get the tables and run those queries, those things that we used for a long time. But now it's better to start moving on. Let's say now you can easily integrate your system, right? Just reaching out to it with a REST API call. And behind the scene, it could be anything. It could be SQL Server or can be anything else. So you can integrate and get this data directly from SQL. We will see it in action in a minute. It's also GitHub Copilot for SQL. We will see that we're going to be able to interact with or chat with SQL using GitHub Copilot. And also, Microsoft has delivered already for the very first time Microsoft Python driver for SQL Server natively. Right? So we have this driver available right now. So more features in terms of high availability, disaster recovery, and performance, right? Many new features in this sense. I will highlight optimized locking that basically in SQL Server 2025, you now have the possibility to enable optimized locking that will handle the internal locking on a better way, and that will give you additional concurrency. What is this? Let's say that you have multiple transactions accessing the same tables. Depending on your data architecture, of course, you may be ended up having some locks, right? So waiting for one session to complete in order for the other to be unlocked or released and be able to do it, right? With optimized lock behind the scene, Microsoft has changed the way that internal lockings work, and you can have more concurrency, and that will give you at the end of the day more performance, right? In terms of performance, if we are talking about it, there are a lot of enhancements related to IQP, intelligent query processing, right? That will help you to obtain something that is quite interesting and difficult to accomplish in SQL, is that everything works always the same way. Meaning that if you have a report that always takes or normally takes 5 minutes to run, right? Doesn't matter if the server is idle, doesn't matter if the server is fully loaded, you can always have the same amount of time, right? This intelligent query processing go in that sense, in that direction. One more thing is query store on read-only replica. Query store is this component that store internally every execution plan, every statistic related to the execution of your query, the runtime statistic, amount of reads, writes, duration, etc., and store it into this, let's say, performance repository. Right now, you can have this query store also in the read-only replicas. Till now, you can only have it on the primary, right? So nothing for the replicas. Now you can have one version of query store for your primary and another one for each of your replicas. And then in terms of improvement in high availability, disaster recovery, right? There are more reliable failovers with availability groups, more tooling to do tuning and diagnostic of those availability groups, and a lot of enhancements in the sense of backup. If we switch for a minute to Azure SQL, right, let's describe them easily one more time, right? We have virtual machines running SQL Server, the same SQL Server that we run on-prem, the same SQL Server that we download from the web, the ISO file, and we stored, but already pre-installed in these virtual machines. What's the benefit of this? Well, first of all, most of the best practices that we've been learning over the years in terms of how to install and configure SQL Server, name it like 10 DB location of the data files, logs files, max DOP, etc., etc., etc. They come pre-configured on this virtual machine. So there are a bunch of things that just by deploying these VMs are already there, right? Then, this enter into a bucket which is called infrastructure as a service. So you have to also manage the infrastructure behind the thing, meaning the operating system, the patching, the backups, the high availability and disaster recovery, creating those clusters, etc., etc., etc. Right? So it's like having your virtual machine locally in your environment or your bare metal server, but in Azure. Then we go to another category, which is called platform as a service. Right? And platform as a service, we have two components, two services. One of them is Azure SQL Database, and the other one is Azure SQL Managed Instance. In both cases, what Microsoft give us is basically a SQL endpoint, right? That we connect with our favorite tool, Visual Studio Code, Visual Studio, anything, right? We deploy our user database and then we start working. We don't have to worry about the infrastructure behind the scene. We don't have to worry about the OS. We don't know actually if it is Windows, if it is Linux. We don't need to handle the patching at all. The backups are also done automatically, right? So it's only a SQL endpoint that we connect, and Microsoft take care of all the back end underneath, right? So super, super cool. So now you can ask me, Javier, why do we have two options, Azure SQL Database and Azure SQL Managed Instance? Well, they are quite different one to the other. Azure SQL Database is one of the first Azure services available since Azure was initially created, right? It's basically targeted to modern application, right? And the main, let's say, characteristic of Azure SQL Database is that your application have to live within a single user database. What does it mean? If I have an application, I have to deploy all the tables, views, store procedures, objects in a single user database. So if we go to SQL, where we can have multiple user databases, and if you have the proper right, you can join tables that are located in different user databases with absolutely no problem. In Azure SQL Database, you cannot, right? Everything has to live within the same user database, right? Then there are some things that are different than SQL Server. For example, you don't have SQL Server agent, right? So there are other things in Azure that allow you to schedule a task and those kind of things, but there's no, it's not exactly the same. That is why Microsoft is saying that it's targeted to modern application. It's super robust, right? Eventually, you can migrate from your SQL to Azure SQL DB. It's going to be really complex because if you have multiple user databases, you may have to re-architect to have everything in a single user database. But then, several years after Azure SQL Database was released, this concept of SQL as a service was quite well get it from the data community. And we say to Microsoft, why we cannot have something more similar to SQL Server with multiple user databases, with SQL Server agent, database mail, and everything that we use and love since 30 years ago, but with the same concept of as a service, right? And this is when Microsoft has released Managed Instance. Again, you have something which is almost 100% compatible with SQL Server, but as a service in the cloud. You don't know what is the infrastructure behind the thing. You just connect over there, you create your user databases, and that's it, right? Doing a migration from SQL Server on-premise to a managed instance is as simple as doing a backup restore, right? Which is not the case of Azure SQL Database, by the way. Right? And also Microsoft have another category which is called edge computing, in where you have Azure SQL Edge, right? Which is the possibility of running the SQL engine on an ARM device. That could be, for example, a Raspberry Pi, right? Or any kind of ARM device that could be a sensor, right? So if you have this scenario in where you have to deploy multiple sensors in a field to, let's say, collect, store, and do some, activities with the data you collect from those sensors. Azure SQL Edge is the way to go, right? So if we try to enumerate some of the benefit of using Azure SQL as a whole, the three components, I would say, right? The virtual machines, managed instance, and Azure SQL database. Let's try to enumerate the benefit. First of all, business continuity and high availability, right? In SQL Server, you can accomplish this, of course, but it's quite complex because you have to deploy multiple data centers, deploy multiple servers, the cluster, the authentication, etc., in order to have high availability. In terms, you have a problem with your, let's say, main data center, right? And if you need, of course, to accomplish business continuity if something happens. In Azure, this is way more simple because Microsoft handle it uh, automatically for you. It's not for free. You have to make some configuration, right? But in the case of Azure SQL DB and managed instance, it's as simple as just checking a checkbox, right? And you will accomplish high availability and disaster recovery. In terms of backups, you can automate all the strategy related to your backups so you don't have to worry about that. And also you can have long-term backup retention and sheer replication of those backups. What does it mean? Let's say we go to the on-premise world. We know that backups is super important to make sure that we have our data covered in case of a major disaster and we need to go back to those backups. There are several best practices, right? One of those is that you cannot have the backup file in the same location as your main server is, because if, for example, there is the whole building gets unavailable because of a major problem, you won't be able to access your server, but you also won't be able to access your backup. So the best practice is that you have to store those backups on a different location and with a long-term retention, right? Not only the last backup, maybe several days or weeks, right? With Azure, you can accomplish this real quick, right? Azure SQL will take care of taking the backups, configuring the long-term retention, and making a copy of those backups into a different Azure region, right? So in case you have a problem, right, you also have the backups copied on a different location. And then to me, the most important and the best benefit in Azure SQL, which is scalability, being able to scale, right? What is this? So let's say that you are on a peak season. Let's go back to the old world when everything was on-premise. You have your server with certain amount of CPU, certain amount of gigabyte of memory, and certain disk. Let's say you enter into a peak season and you have a breaking record sales, and you have 3 times, 4 times, 10 times more transaction than during the normal year, right? Definitely, you may need to scale up your SQL Server. Otherwise, you will have a bottleneck, and probably you won't be able to fulfill the business requirement, right? If in the on-prem world you have that situation, you have, let's say, 90+% CPU usage all the time, well, you may probably need to put more CPU, more memory, or better disk. Right? So can you do that? Of course you can, right? You have to contact the vendor of this hardware. You have to verify what you have and ask for the new hardware. Then they have to ship the components to your data center, and then you have to schedule a maintenance probably with a technician or an engineer that will be able to reconfigure your server with the new component. That's going to take some days, even weeks, right? And let's say that you don't have that time available for you, right? In Azure SQL, with few clicks, you can scale up any virtual machine, any Azure SQL DB or managed instance, moving to a different tier with better disk, more memory, and more CPU in a matter of minutes, right? And the good part is that, let's say that you finish the peak season and you go back to your normal season, you can also scale down, right? And go back to your original configuration. So you save some money, right? So scaling in Azure as a whole and in Azure SQL in particular is something super easy to do. Of course, it costs, but you can accomplish it in matter of minutes, right? So super cool. Then all the security that you have in SQL Server, plus the benefit of the security in the Azure platform, right? Those are the most important benefit that we have in Azure SQL. Then let's jump to SQL database in Fabric. This service was in preview for quite some time, but now since last November is GA, right? And as we briefly mentioned before, in Fabric, the analytical platform, you can create lakehouses, data warehouse, work with Python, with R, with Scala, use Data Factory to ingest data. You can do any analytical project end to end, including also with Power BI, right? Well, now you can also create a SQL database within Fabric, right? Which is the objective of this? First of all, right, make a simple platform. What is that? In Fabric SQL database, you just go there, right? Hit new database, specify the name, and boom, ready. You have your user database. If you're coming from the SQL world, on-prem, virtual machine, or even Azure SQL, there are some nodes that you should do, right? Configure the service tier, the amount of cores, the IOPS on the disk, and many other things. In Fabric, you just specify the name and that's it. So that is why it is that simple. It's trying to go on this way of being autonomous and secure. Secure, of course, as everything in SQL, and autonomous for you not to have, let's say, a DBA team all the time, making sure that you do performance analysis, availability, and those kind of things. And finally, it's optimized for AI. Right? The same feature that we saw in SQL Server 2025 with the vector data type, with embeddings, etc., are also available in Fabric SQL DB. Here are some of the things that we can do in Fabric, in SQL databases in Fabric, right? Then we have the integration with Microsoft Fabric. What is this? We need to bring the data into Fabric, into one lake, which is the storage component in Fabric, right, as quickly as possible, so we can do analytics based on near real-time data, right? So in this slide, it's not correct because it said that this is still in preview, but everything is GA by now, right? So there is this feature called mirroring, right, that allows you to mirror from any SQL version from SQL Server 2016 till 2025 into one lake. Also, of course, Azure Database, Azure SQL Database, and Azure SQL Managed Instance. In near real time, you can bring your operational data. Let's say that you have your line of business application running in at the top of Azure SQL Managed Instance. Every time that there is an insert, update, delete of the data, so you have new product or your stock change or anything, right? That data will be reflected into one lake, so you can do analytics using real-time data. Then we have Copilot in SQL, right? And in order to do that, Microsoft has provided two, let's say, what they call skills. The first one is a skill which is mainly targeted to database administrators. and the other one is targeted to developers, right? What is this? Well, you know Copilot. Copilot is this tool that allow you to interact with your user databases, with your SQL Server instances using natural language, right? Plain English, plain Spanish with absolutely no problem. So if you target the database administrator skill, you can ask Copilot, right, which is the SQL Server version that I'm running on, which when was the last time that I performed a database backup, which is the fragmentation level for my index. Do I have blocks on my database? Why my database is slow? We can ask all these kind of things, and Copilot will do the analysis for us and will give us the answer. The other skill is the one targeted to developers, right? In where you can, let's say, let's imagine this scenario. You enter into a new shop position in a new company, and they give you a user database, right? Which is your line of the new line of business application, and you know nothing about this. You know that the business is, for example, sales, right? But nothing else. So you don't know the table name, the column name, the relationship, etc. Right? So you can start talking to Copilot, chatting with it, asking which are the sales from last quarter and compare the sales from this quarter versus the previous quarter, right? And what Copilot will do will analyze your metadata, will analyze the data structure, and will come up with the result of what you asked, as well as the T-SQL query that was used to generate that output, right? This is super, super interesting. And again, it's fully integrated with Azure. Now we will see it in action with a demo, and you can use natural language. So why don't we see all this in a demo right now? So let me switch to my virtual machine. Here is my virtual machine running SQL Server 2025. I have multiple databases in here. And let's say that I have the adventure world. So I will open a new query, right? And here at the top, this is Management Studio 22, by the way, the latest and greatest version. We have Copilot, right? Now is popping up. And what is important to know about Copilot is that if your login, your credential give you access to only one table, right? The answers that Copilot will provide to you are going to be based only in that table. So it will use your credential, your existing connection against SQL to get whatever it needs to retrieve, right? So it's not like it has some sort of superpower to get everything. No, it's going to use your connection. So if we start asking, we can say, what is the weather like now, right? So we can chat with Copilot, right? So this is what Copilot is at the end of the day, right? We can also, let me start a brand new chat. I was playing around before here. So what is the weather like? And it's going to take some time, right? Especially at the beginning. And in the meantime, let me open some thing, right? And it's analyzing my database, and the answer here will be, hey, I'm a GitHub Copilot. I can only give you answers related to SQL Server, nothing related to the weather information, right? So now I have some sample questions, right? I know that Adventure World is a system that stores sales about bicycles and those kind of things, and it has the whole HR module and everything underneath, right? So I will ask to Copilot, calculate the average vacation hours paid per title, right? This is a question that in order for us to get the result, we need to understand the data structure, the tables, the columns, the foreign keys, the relationship, and then build the query at the top of it, right? So as you can see, I haven't opened the Object Explorer. I don't know how many user databases I have. I don't know the table names, right? And what Copilot is doing right now is analyzing the metadata underneath, and it will come up with the answer to my question. It will calculate the average vacation hours per shop type. At the beginning, it may take few more seconds than if you use it more and more, right? Because again, it's doing this discovery underneath. But believe me, it's gonna come up with the result in few seconds, right? In the meantime, we can also say, let's prepare the next question. Find employees hired after 2010 in a specific department. We just put this one in the clipboard to us. And believe me, you can spend the whole day asking Copilot, and you can do reverse engineering and get all these answers, right? Another thing that is quite interesting with this is that let's say that you have a store procedure, right? And you would like to know if it is written according to the T-SQL best practices. Right? You can also say, hey, Copilot, analyze my store procedure and provide me with suggestion on how to improve the code. Right? That is super cool. So here we have the answer to our previous question, which was the average vacation hours per shop. Now we're going to ask, find employee hired after 2010 in a specific department, right? And again, I don't know the tables, I don't know the relationships, but everything is. I mean, Copilot will do everything for me. Let's wait a few more seconds, and then we will ask another kind of question more related to a TBA skill. So again, it's warming up. The database is a little bit bigger than I would like. So that is why it's taking a little bit longer. But as soon as you start chatting and dialoguing with your SQL Server instance, right, it's going to come up with all the answers. Right? This is using behind the scene GitHub Copilot. So if you have a GitHub Copilot license, you download Management Studio 22, right? You configure it right there. It's going to use that license, and you can start having this kind of chatting with your SQL instance, right? If we go for a minute to my previous answer, it's not only the result that it gave, but also gave you an explanation of what was done in order to retrieve the output. The output is table, right? SQL Server, we do a select, we get a table. So the end result is going to be that. Right? But I mean, today maybe it's taking a little bit longer than usual, but it will come up at the end. Okay, let me run out of time. Let me cancel it, and I will do, for example, which SQL Server version I'm using. This one should be faster, right? Because it doesn't need to go to SQL data to any SQL data and scan any metadata. But today is taking maybe longer than usual. And again, we can ask when was the last full backup. Yeah, here we have the latest. Here we have the information. It says SQL Server 2025, Enterprise Developer Edition, blah, blah, blah. When was the last time I did a full backup, right? I mean, all these are things that we, the DBAs, we have scripts to do it right away. So we have our toolbox over there, right? And we should go open that script and we run it and we get, the SQL Server version, we get the date of the last full backup, etc., etc., etc. We can get, the fragmentation level, but here, this is a new interface in where you can interact directly using natural language. That is why it is that powerful. Is my database slow? Right? And now it's going to go a little bit deeper and check all the dynamic management views and functioning where SQL use to store and present the performance information. And if there is, any blocking or locking or anything like that, it will tell us. And eventually, if we have a suggestion like, for example, create a new index or something like that, it's gonna return. As you can see here, it's running multiple threads, it's preparing the script underneath, it's doing this analysis, and will return with the result, right? Well, that is Copilot in SQL Server 2025. So with that, we just conclude the presentation. Again, my contact information here is available, and reach out to me if you have any questions. I see that there are some questions, Constantino.
Yes, thank you, Javier. A great presentation, I have to say. We have one question for Dub. So Dub, is the translator layer from GraphQL schemas to SQL?
Well, you have to do some sort of configuration at the top of it, right? You have to, first of all, install and configure the application, and then point it to a specific store procedure and configure the parameters that you may have to use to do push or a get, right? So it's not a translator. There is a work that needs to be involved by the administrator, by the developer, in order to generate the proper API to the specific content to the database. So it's not a one-to-one relationship that you can say, hey, give me all the data for this specific table, like a select star. No, you have to go and configure the API call to a specific table, specify the parameters, etc. Right? So there's some work to do behind the scenes before starting. Let's say before presenting the REST endpoint for other applications to consume.
Understood. I hope our viewers are satisfied with the answer. I am. So again, Javier, thank you so much for coming in Azure AI Connect 2026. Excellent presentation. A lot
Thank you so
to
much.
learn and consume.
All right. Thank you. See you
We
soon.
hope you see you again. Yes.
With the
Have a
event.
great one. Have a great one, my friend. Bye bye. That was it from Javier Villegas. Always great content from Javier. And whether you are watching the recording or you're live, we are moving on to our next speaker. No need for intermission right now. He's already ready. And he's the great Jim Bennett. I'm going to bring him in our screen. Hello, Jim. Welcome to Azure AI Connect and to our channel.
Really excited to be here. Thank you for having me.
Thank you for coming, and thank you for taking the time to create the content and the presentation. We are excited to have you. Once more, we appreciate your time. The stage is yours, my friends.
Awesome. Thank you very much. Can we get my... There we go. Brilliant. Thank you. Sweet. So I'm here today to talk about evaluation-driven development of AI apps. Now, you've probably been bombarded with a lot of AI over the last few days. Obviously, this is still talking about AI, but I'm going to be taking a slightly different take on this. This is where we're going to get a little bit negative about AI. We are not going to be, yay, AI is going to save the world. Here we're all about, AI is a terrible thing. Yes. Now, I like to start off whenever I talk about this by generally asking the audience, who trusts AI? Now, every time I ask this question in a room full of people, pretty much no one puts their hand up. Most people do not trust AI. And as we're going to see, with very, very good reason. Now, there's a whole lot of data that's coming out at the moment about the fact that your AI project will probably fail. I imagine if you're watching this, you are either doing something AI related at work, or you at work, people are talking about this. There's a lot of this, thou shalt do AI, coming down from the C-suite, coming down from the upper levels. You know, people are being told they have to use AI, they have to build AI into their applications. And chances are, if you are building an AI project, it will probably fail. There's been a load of surveys done recently. Rand Corporation did a study a few months ago, and they reckon more than 80% of AI projects will fail. MIT put that number at 95%. And there's been other surveys done, again, in that same kind of ballpark. Essentially, the majority of AI projects will fail. Now, software projects failing isn't unusual. It's kind of typical 50% of software projects will fail. You know, by whatever measure you define failure, whether it's like budget overruns, project not applicable, you know, teams being disbanded, whatever, you know, it happens. A lot of time with software, we're exploring new systems, building new products. We don't really know how well it's going to work until it's done. But with AI, the percentage of failure is substantially higher than normal software. And generally, this seems to be caused by kind of lack of direction, lack of really understanding what the project will do, wrong technology choices, and really just not being able to prove that the product you've built will actually do the job. You know, you will build it, you'll chuck AI on it, you'll test it out, and then you'll roll it out to users, and then it just won't work. And a lot of this comes down to just people just don't know how to build in that reliability from day one, build in the understanding of what the project should do, and then actually test their project before it goes out to their users. Now, my spicy take, I do have a bit of a spicy take on AI. And I think this AI generated image of a woman eating ice cream really sums up my spicy take, is that AI sucks. Yes, we are starting to take off being really, really negative about AI. You know, we get bombarded with all the companies trying to sell us the latest AI toys and their latest hardware, telling us that AI is going to save the world. AI is amazing. But let's be honest. Let's take the view that AI sucks. It's a really good place to start from. I'm a natural cynic, and so I'm very cynical about AI. And in fact, we see this AI sucking all the time. One thing I love about this talk when I give it is I can find so many examples of AI mistakes. It's really easy. We see them on the news, we see them on LinkedIn, we see them on social media, everywhere, things that AI got wrong. So I love this one. This was from May last year. The Chicago Sun-Times, a newspaper, you know, that's supposed to have journalistic integrity, published a summer reading list of books that don't exist. The journalist did not fact check the information. He asked ChatGPT, give me a summer reading list. Some books exist, some books did not. No checking it. And this is a bad thing. Number one, we're supposed to trust the news for most news on the planet. But also this highlights that not only is AI problematic in that it can generate wrong information, it's also problematic in the human perception that it works. So the issue here is not just the AI generated the bad reading list, but it's the assumption that it got it correct. It's the assumption by the journalist that there wasn't hallucinations there. It's this idea that we're used to Googling something and trusting the Google results. Therefore, if we chat GPT something, we can trust the chat GPT results. And so AI is sucky because it does the wrong thing and then humans believe it. And we see this so many times, whether it's, you know, people ordering 260 McNuggets or 8,000 bottles of water from Taco Bell, or the Alabama prison system for hiring a law firm to defend itself that used AI-generated citations. So a nice score against the prison industrial complex with that one. Or even this one from Tuesday, where judges in India were using AI-generated orders that are being cited in legal cases. As I say, I can come up with examples of this pretty much every day just by going through social media and the news. There's so many instances of these AI tools that are fundamentally broken. And there's this general perception that it works, therefore we don't need to prove it. And this is where we're thinking about AI wrong. There's this too much assumption that it works. And so you imagine the systems being used here, these are the projects that are going to fail because we assume that they work, we roll them out to production, they cite fake cases, people panic, they've been the project. This is why AI will fail. Now, I've heard some great ways to describe generative AI. Classic examples like it's an enthusiastic 5-year-old with a stack of out-of-date encyclopedias. Really wants to be helpful, really wants to tell you the answer. Answers are out of date or wrong, but it's going to go, yes, I'm going to tell you this. It's going to get so excited about telling you great things. OpenAI, their ChatGPT models are terrible for being excited about helping you with wrong information. But it's true. Wants to help, doesn't always get it right. I think as well, we also need to stop humanizing AI. AI stands for artificial intelligence. That term was really just a marketing term to get more funding back in the 1960s for research. It is not intelligent. It doesn't reason, doesn't think, doesn't make decisions. It's just an autocomplete that's trained to be confident and potentially sycophantic. That's all it is. These reasoning models just use essentially be spicy autocomplete to change what you ask it to do into a different set of things that autocompletes and autocompletes and autocompletes. It's just autocomplete. It's very, very powerful, but it's just autocomplete. And I want to make sure we kind of set this baseline of just how bad AI can be. And also, the fun of AI as well, from an engineering perspective, is its lack of determinism. AI is non-deterministic. One of the interfaces we use for AI is a chatbot, and that way we have non-deterministic inputs because we can ask the same question 100 different ways. And then when the AI runs, it has randomness built into it. Some of this is built into the models. And yes, you can tune values like temperature and top P to try and reduce this randomness, but randomness is baked in. You also have randomness built in just the natural parallelization of some of these tasks. The order that they complete on the GPU can give randomization. The GPUs that's run on give randomization. And so essentially, the inputs you put into LLMs, generative AI models, will give different outputs every single time. It can work one day, not work the next. We've all seen systems that pass all the tests and then fail day one in production. This is what AI does. You can run it in tests and it works fine, roll it out to users and it will fail because it is non-deterministic. So this is the negative part. Now we can turn it on its head a little bit and talk about what are the good ways? How can we overcome that negativity? Well, the main thing to say is that when AI does work, when or if it does work, it's actually really, really good. It is amazing at taking unstructured data and then reasoning, humanizing there a little bit, but looking at that unstructured data and bringing together conclusions from it, tying things up it's not just like a join on two tables. It's here's this data, look at this, come back with information about it. It can understand a user's intent. It can, to a certain degree, make decisions. It can select paths in code based off information it's gathered from disparate systems. You don't have to have a strong contract to an API anymore. It can work out from an API what needs to be done. It's not just reading API docs and calling things in a deterministic fashion. AI can work these things out. So it's not all bad. When it works, it's really, really good. But because I know that AI is bad, and because I want you to realize how bad AI can be, I want you to think about approaching AI from a cynical perspective. Approaching AI from the perspective of assuming it doesn't work until you can prove that it does. And that's really the key thing we're going to be talking about today is how do I prove that my AI is working? And then how do I define what working actually means? So let's just start with some demos because, we are engineers, we like a bit of code. So I'm going to jump into a little demo of a very contrived, mocked up HR type system where I want to find out how many vacation days I have left. So I'm going to zip over here and I've got a bit of code here. This is some very, very simple code using the OpenAI SDK. It's in Python. I have a system prompt that instructs the AI to be a helpful HR assistant, giving clear, short, succinct answers to users' questions. And then I'm going to ask the question, I'm in the UK, how many vacation days do I have this year? And I'm going to run this against GPT-4o Mini. And as you can imagine, I'm running this on Microsoft Foundry. So I've got a model here. It's deployed. It's a nice, cheap model running on Microsoft Foundry. And I'm going to run against this. Okay. And it's come back to tell me that I have 28 vacation days this year, which is interesting. Let's do that again. Oh, now it's telling me I've got 25 vacation days this year. What's next? 28, 28, 25, 28. Your employment contract specifies 25. Okay, interesting. I'm now saying my employment contract should specify my vacation days. Check that document for the specific number. Now, I'm not changing anything. I'm running identical code. And my code asks, I'm in the UK, how many vacation days do I have this year? And I'm not actually providing this information. Now, in a real-world HR system, you would do some form of lookup to get this information. But if that lookup failed, for whatever reason, and that information wasn't available, the AI could make it up. That's what we're seeing here. The AI is making up this number. Now, there's logic behind the number. In the UK, the legal minimum is 20 days plus 8 bank holidays. So 28 vacation days is right. That's the legal minimum. 20 days plus the 8 days bank holiday. 25 is more of an average, not including bank holidays. So a lot of people get 25 days, and then they have the 8 days bank holiday as well. But actually, the only correct answer here is this last one, telling me to look at my employment contract. In fact, my system prompt says, answer based off the employment contract. But every time this AI has been really helpful and tried to give me information that is fundamentally wrong. So in the real world, if this was connected to some kind of lookup, the lookup fails and the LM hallucinates, I could say, yes, my HR chatbot tells me I've got 28 days vacation left. You know, I'm going to take the whole of November and December off, even though I've already taken time off. So here we're seeing it being wrong. Very, very worrying. Very, very worrying indeed. So what do we as developers do to ensure that our AI doesn't suck? How do we test this kind of code and prove that it's actually working, or in this case, show that it's not working? Well, this is where we have a bit of a problem. So over the past, 40, 50, 60 years, software engineering as a discipline has kind of evolved. People like Grace Hopper kind of advancing this idea of software engineering, trying to build a discipline of practice in there. And we've got really quite good at knowing how to validate our software. Whether you think about waterfall models or agile, we always have this concept of testing in there. We can think about good requirements analysis, building automated tests. And we've got to the point where our CI/CD pipelines have got unit tests and integration tests and end-to-end testing. And we are quite good at doing this. In principle, I know there are people out there who don't bother to write tests. And I'm not mad, just disappointed. But, we have got quite good at running tests. We've got quite good at doing this. But these tests rely on determinism. How do we unit test something where the output can vary? In the case of these chatbots, the output can be very, very different. The output is non-deterministic. Now, you could say, yes, I've looked at output and we can look for 25, 28, and these are wrong, but there's so many different ways that output could come out. And in this particular case, this is a very, very simple contrived example that's just going to spit out the number of days. But what if this was a multi-agent system with multiple tools where the non-determinism occurred at the original LLM call and the tools it calls and the processing those tools with an LLM, then another set of tools? This really complex AI systems. That non-determinism kind of compounds every single time. If we were to ask the HR chatbot, how many days vacation do I have left? I want to take 5 days off in August. Is this possible? And how much would I have left after that? There's kind of so much complexity in that question that we can't just kind of do a simple unit test on the answer. Now, historically, we've done this test-driven development. This is kind of a good way to deal with deterministic code. This is kind of a good engineering practice that we've established over the years. We can work out what our application should do, build a load of tests to show that this is what the application should do. These tests will initially fail, and then we write code, we ship the code, our tests start to pass, and then once our tests pass, we can then improve the code. We kind of get this test-driven development cycle. All of our requirements, all of our business knowledge, all of our product needs, whatever, get built into a whole lot of tests. This is our framework for evaluating whether our application works. We make our test pass by writing our code. We then have that, we understand that our code works. We can refactor, knowing that there's safety in our code, and then the cycle completes. Our tests define that business knowledge, that defines the domain knowledge, defines what application can do. This works so well with deterministic code. If we wanted to build, say, a web app to look at our number of vacation days, this is easy to do. We can write an integration test that puts some numbers in a database, pulls those numbers out via an API, and checks whether the numbers are right. We can write a unit test that says that takes the results of that API call and puts it into a React component. We can write an end-to-end test that spins up the HR portal and then gets the seeds the database and looks at the numbers on the screen. We can build really good deterministic tests for this. Doesn't work for AI. Doesn't work for AI because there's so many ways you can interact with a chatbot and so many ways the response can come out. There's so much non-determinism there. Now, when we build our normal tests, when we write a unit test, we usually follow a pattern known as arrange, act, assert, or also known as kind of given, when, then. If my system's configured a certain way and I do a thing, I can then look at the deterministic output that comes out and say, is this what I expect it to be? I put some numbers in my database, I call an API. Is the API result the numbers that I've got? Great, fine. Doesn't work for AI. Now, if we try to think about how we can apply this to AI, our first problem is that our arrange space opens up into a really huge problem space. Okay, this is kind of something that's relatively easy to solve, but we have so many different ways of doing the same thing if our AI interaction is text-based, if we're working with something like a chatbot. So for example, rather than just going into an HR portal and clicking the leave button, I could ask questions like, how many vacation days do I get each year? Or how many holiday days? Or how many PTO days? British people say holiday, Americans say vacation and PTO. There's different words for it. I can say, can you tell me my total annual leave and what remains? How many paid leave days are still available to me? Give me my PTO totals. I want to plan time off. How many days have I got left? Here's just like 20 very quick examples of how we can essentially ask for the same thing. It's not one test where I call an API. It is, here's 20 examples. And these are very simple examples where I'm just asking for information. I'm not saying, I want to take this number of days that will split between this year and next year. How many do I have for this year? How many do I have for next year? Can I get approval? There's so much we can query. And this adds a little bit of complexity, but it's not huge because we can just expand our range. We can literally build thousands upon thousands of unit tests. So, not a huge problem. The problem really comes, though, with the answer. When we do our assertion, we have problems. So if the correct answer was 30, for example, how do I assert that my answer is 30? Because the response to my AI could be, you have 30 days vacation a year as a number, or you have 30 days holiday per year as text, or you have 6 weeks, which is 30 days. All of the right answer, but they're expressed differently. So suddenly this concept of asserting becomes a problem. I'm not just asserting on a number that comes out of a system. I'm asserting on a very humanized response that's text-based. And this becomes problematic. I can't really do a traditional assertion. Yes, I could write an assertion that says, if I'm expecting 30 days vacation, 12 taken, 18 remaining, I could say, look at the output, make sure it contains either the number 30 in text or words and the number 18 in text or words, the number 12 in text or words, and either 30 and 18 or 12. But, there's still no guarantee. It could say you've had 30, you've got 18 available when it's actually had 30 used, 18, 12. There's just so many ways you can do it. You can't just write a simple basic test to do this. The assertion part fails. So what do we do? what do we do? Well, I started off by saying that AI sucks. There is one thing that AI is good at. AI, as it turns out, is as good as a human at testing the output of an AI. You can essentially build what we call an evaluation or an eval. And this is where you use an AI to evaluate the outcome of the AI. And studies have shown that AI is as good as a human at doing this, which means not perfect, because let's be honest, humans can suck as well. But it means the AI is actually pretty good at judging the outcome. You define some metrics, you essentially build a prompt that tells the AI what to look for in the output, and the AI is really good at testing that. So there's a lot of complexity here. You've got to kind of build a prompt for the AI to do this, but essentially it works. The AI is really, really good at testing the output of the AI. Now, obviously the best answer would be a human to do this, but if you're dealing with thousands, millions of tests, humans get expensive, they are very, very slow, and humans get bored very easily and make mistakes when they're bored. So, for the first 5 or 6, the human's there, but after a while it's like, yeah. Not great. An AI is a lot more reliable. It's as good as a human, doesn't get bored, faster, cheaper. So let's actually do this. Let's actually have a demo of using an AI to test the outcome of our HR chatbot. And I'm going to use an open source tool. It's called Phoenix from a company called Arise. I'll dig into this a little bit later about the actual product, but essentially it's an open source LLM tracing and evaluation tool. So completely open source, completely free to get going. I've got this running in a Docker container locally, but you could run this. I would have deployed it to ACI, but I just wanted to keep my Azure credits down for the month. I'm spending a lot on LLMs tokens at the moment. So just to kind of keep my costs down, I'm just running this locally rather than on Azure. But you can literally get a Docker container for this and host this. So this is Phoenix here, so running locally, and I've got a couple of projects in here, nothing here at the moment. And then I've got some code here. This is exactly the same chatbot code we had before for the HR chatbot, but I am setting this up to send information to Phoenix. So I'm starting off with just some traceability information. So if you've done OTel, if you've used tools like Datadog, Sentry, or what have you to upload telemetry information, what I'm doing here is essentially the same, but specialized for AI. We'll dig into this a little bit more later on. But essentially what I'm doing is I'm hooking in to OpenAI. OpenAI, the SDK, has kind of tracing for what the LLM is doing. And I'm just connecting that up to Phoenix. One thing that's really quite nice about Phoenix is I literally drop this one line of code in here, and it just works with all the different frameworks and SDKs that you want to use. So I've added this. I've got this pointing to my endpoint on localhost. Not going to show my API key, but that's it. One line of code. And now if I run this, we'll get exactly the same output. There you go, 28 vacation days this year. But what's happened now is that's been sent to Phoenix. So straight away, I've actually got a little bit of an overview of what the AI is doing. So this is the call. It's a chat completion using LLM. It took 802 milliseconds. 87 tokens, 77 in, 10 back out. This is my system prompt, my user prompt, and my output assistant prompt. And look in more detail. This is the raw output from OpenAI, including the output, filtering, model calls, tokens, all that kind of stuff. So straight away, I've kind of got that observability. So just as kind of a top tip, if you really want to understand what your AI application is doing, this is the kind of tool that will show that. And you imagine you've got like a multi-agent system with tool calling, you're going to end up with really kind of complicated graphs of calls. You will kind of get all that rendered in here. So really, really quite cool for seeing what your AI is doing. But the bit we care about is this concept of an eval, of using an LLM to check this answer. The answer is 28 vacation days. Let's test that with an LLM. It's got a bit more code here, again using Phoenix. And what this will do, this will go and load that trace. So this will download that information I've just uploaded to Phoenix. I'm then going to split it into 3 values: context, input, and output. Okay. The input is the question from the user. How many vacation days do I have? The context is any information that I've applied to that. In this case, just the system prompt. And then the output is response in the LM. You have 28 vacation days this year. So I'm just extract this information from the trace. And then I'm run this information through an evaluator. Now, an evaluator is literally just an LLM call with a prompt that is designed to evaluate the outcome against a certain type of criteria. This case, I'm doing what's called a faithfulness evaluator. So this is one that's built into Phoenix. You can build your own evaluators with whatever prompts that you want. But this one, the prompt here is essentially, given this input and this context, is the output faithful to the context? So it's kind of really good for RAG-based systems. Essentially, this is saying, I got an output saying 28 vacation days this year. Is this output actually grounded in the information that was passed in the input and context? Is this 28 days grounded in this user prompt and this system prompt? And that's what we're testing. This goes off to an LM. We'll actually dig more into prompt in a little bit, but for now, that's basically what it does. I then evaluate this. I take my trace and I just test them all against this evaluator. So it uses the LM to judge it. I'm just pointing this at my OpenAI deployment, same as the LM model. And then when I've done this, I then re-upload those values back to Phoenix. So I've got a place to look at them. I'm dumping them out locally, but I'm also putting them up in Phoenix so I can see them. So if I just run this so you can see what I mean, it's going to run, evaluate, and then here's the output. And the faithfulness down here is a score of 0. And what's really cool is, as well as this prompt evaluating the faithfulness, it also returns an explanation as to why it gave that score. And the explanation, the response provides a specific number of vacation days, 28, without any context or information from the user's employment contract to verify accuracy. Since there's no context provided to confirm that user indeed has 28 vacation days, the response may be considered unfaithful. So it's saying basically the AI hallucinated. And this, as I said, is sent back to Phoenix. There we go. There's our faithfulness score, 0. And this is the average one for all the traces it's captured, score of 0. So we looked at it, we've seen the eval number, and now we can use it to fix our code. We've basically done a test against the output of an AI, the output of the LM, and now we've done a test, we can fix it, and we can then use the same test to prove that we fixed it. So if I just zip over here, I've got another version of the same thing. So what's different here is in my system prompt, I've actually mocked out the RAG part. I've mocked out the database lookup against the number of vacation days. And I'm saying that the user employment contract stage got 30 days. They've already taken 18 days. So if I now run this, what we should get back from the LM should be the right answer. There we go. You have 12 days of vacation left this year. And we should see that here. Here we go. This is that one, 12 days of vacation left. And then I'm going to go back here. I'm going to rerun the same eval against that. Evaluating. And here we go. Score 1.0. The context states the user has 30 days of annual leave and has taken 18 days, which means they have 12 days remaining. The response correctly reflects this calculation. And back into Phoenix. Give this there we go. 1.0. It worked. So what we're seeing here is we had something that didn't work, an AI output. We can't really write a simple unit test against that because there's so many different variations of what can come out. So instead, we're using an AI to look at the output and determine whether it works or not. So kind of just shifting that testing mindset away from the deterministic test that we used to encode into an AI-powered test. So how does this fit into our SDLC, our software development lifecycle, or our ADLC is the new hotness, the new hip term, the AI developer lifecycle? How does this fit into that? Well, if you think about like test-driven development, we've had this idea of arrange, act, assert. We set the system up, we do something, we take the output of that something and assert against it. We know we can't do that because the output is non-deterministic, but instead we can add an evaluation step. So we go to arrange, act, evaluate, assert. Set up the system, do something, use an LLM to convert the output of that action into something we can assert against by using some kind of valuation, and then assert against that. In the case of what we've just seen, the evaluation took the response to the LLM, ran the faithfulness over it, and returned a score of either 1 or 0 for faithful or unfaithful. And we can assert on that score of 1 or 0. So let's actually show that now. If I go over here, I've got a slightly different version of the chatbot here. This is pointing to a different project in Phoenix, just to keep it easier. I've got my chatbot, and this is a bit more real world in that I've got a tool. So I am my system prompt, basically the same as what we had before. I then have a tool, this get vacation days for user function that's called. I then call my LLM. If response says call the tool, I call the tool, send that back to the LLM, spit it out. Fairly boring, dull OpenAI example with some tool calling. And right now my tool call is just hard coded. But again, this would be the thing that will go off to the actual HR system and pull back the right number. So in my app.py, I'm setting up Phoenix, and then I'm just calling this. And because we're hard coded to 30 days and 18, this should return 12. While that's running, I'm just going to flip to my other project where that lives. There we go. Here it is. And we're seeing again more detailed trace. I've got the system prompt, my user prompt. The assistant comes back and says call the tool. Here's my tool result. Final output, 12 vacation days. There we go. It's in there. And we'll see here 12 vacation days. So I can now take this. I can take this code. I can take the bit that calls the LLM, and I can build a unit test against it. And I have a unit test here. This unit test is basically the same as what we had in the eval in the last example. I got my faithfulness evaluator. My test has got 20 cases. I want to make sure I test a wide range of inputs. I've got things like how many vacation days do I get? How many holiday days have I taken already? How many PTO days do I still have left? And so on and so on and so on. I've got some mocked up data for the number of vacation days. So in my standard test arrange that we have, I mock out my get vacation days for user function to take the information from the test case. My act, I call the chatbot with the prompt inside my test case. And then I'm just sleeping for a couple of seconds to make sure everything syncs up to Phoenix correctly. Then my evaluate step, this is the new step. Arrange, act, assert becomes arrange, act, evaluate, assert. My evaluate step, I'm downloading the trace. I'm pulling out the input, output, and context. In this case, I'm ensuring that my context has the system prompt and the output of the tool call. Yeah, I'm kind of just hard coding because I know what things are. The 0th and 3rd message, which is 0 being system prompt, 1, 2, 3 being the tool results. So I'm basically making sure of all the context. Yeah, I could pass the entire chat history, whatever, but yeah, it's just you would write this based off whatever your system is doing. So that's the context there. I then evaluate this. I'm not annotating this back up to Phoenix and just run this locally because it's a unit test. I'm putting out the score and the explanation, and then I'm back to my standard tester and develop my assert. I assert that my score should be 1, and if it's not, I dump out the explanation. So I can now run this. If I run it through PyTest, standard unit test, I'm running this locally, but I could do this in my CI/CD pipeline, do this before I release. This is now running this evaluator as a unit test. So if I go back into Phoenix, should start to come through. Here we go. And while this is coming through, I'm just going to take a moment. Oh, not that one. It load. Hey! Stop loading so quickly. Don't you hate it when it loads too quickly? Here we go. Just have to take a look at this one. Where I am tracing. Now, remember I said when we did that Phoenix register, that hooks into all the OpenAI calls. That hooks into all my LLM calls. And one of the LLM calls I am making is this evaluator. The evaluator is called against the LLM. And so I can actually see the trace that is sent in Phoenix, which is really quite useful. So I'm seeing here my faithfulness evaluator, the input, an email vacation summary, output, total 15 days, unused 10 days, left 5 days. And then here's the context that was sent. So this is everything that was sent to the evaluator that I can see. And here's the score. But what's really cool is I can actually go into this, and I can actually see the prompt that the evaluator uses. So as I said, these evaluators that powered by LLM, we need a prompt to tell the LLM how to evaluate the output of the system. And so here's the actual prompt. In this task, you were presented with a query, some context and response. Response is generated the question based on the context. Response may contain false information. You must use the context to determine if response question contains false information. So we kind of prompt it. It's got what the prompt should be doing. It's got the kind of instructions there. It's got a rubric for how to score this, and then it's got a thing to say when you return a result, either return faithful or unfaithful, and it should not include any other text or characters. So this is the bit where we're converting that non-deterministic output into a deterministic output, either faithful or unfaithful. That comes back from the LLM, and then once that comes back, there's this structured data that comes back that's got faithful, unfaithful, and an explanation. And so we are converting that non-deterministic value into a deterministic piece of information here that can then be used. Here you go. Here's the content, explanation, label. And then the evaluator code will take that label, faithful, unfaithful, and convert that to a final score. So this is the final output here. It adds the score based on this is faithful or unfaithful. So we're kind of bringing that determinism into this. Very, very cool. And here we go. Here's where my tests run. Now, one thing that's really interesting here is this. All my tests did not pass. All these tests should have passed. So actually, this is a very simple application. I would expect it to work 100% of the time. But actually it didn't. It failed. One instant failed. And let's look at this. Okay. Expected faithful score of 1, but got 0. Explanation. The response states that the current vacation balance is 14 days. However, based on the context provided, the total vacation days are 22 and 8 have been used. Therefore, the current balance should be 22 minus 8 equals 14 days, making the response correct. However, the response does not mention the used vacation days or total vacation days as required by the task guidance, need to be considered unfaithful for not clearly out the calculation despite being factually correct. Now, that's an interesting one. We got the right answer. We got 14 days. But the LLM judge goes, well, you should have said it's 22 minus 8 equals 14. You should have said the 22 and the 8. Which is kind of interesting because is this right or is this wrong? Our system prompt says, provide very clear, very short, succinct answers. Your current vacation balance is 14 days is a short, succinct answer. Doesn't provide the extra details. But the judges decided, well, actually, you should have provided the extra details. It's kind of interesting it does this, because this is the kind of issue that both humans and AIs have. Yeah, I said humans and AI is as good as a human, not perfect, because we have this kind of, is it right, is it not right kind of idea. Because the fact is, AIs suck, AIs get things wrong, and so using AI as a judge can also get things wrong. And that's really important. The AI makes mistakes. And so this is another slight difference between traditional testing methodologies and evaluation-driven development. With the traditional testing methodology, we expect all our tests to pass. We run our acceptance tests before we release to production. We want them all to go green. If it doesn't go green, it's like a flaky test. We can rerun it, it will work, and we try and fix the flaky tests. With AI, there's no guarantee it will get it right. Partly, the LLM as a judge can make mistakes, as we've just seen. That's kind of a mistake in interpreting the answers. And also, your application will not necessarily get it right. The AI inside your application will get it wrong. And so you have to accept a certain percentage of failure. You cannot have a 100% pass rate. And so one thing you need to decide is, what is the acceptable pass rate? If you're working in a heavily regulated environment like a bank chatbot, you probably want your pass rate to be really high, 95 to 100%. Unlikely to ever get 100%, so maybe 95 to 99. In something else, in like entertainment, retail may be lower. You know, if your chatbot doesn't quite help someone find the thing they want, they might just go and search the website anyway. So you may not lose a customer over it. So you've got to kind of work out what that sweet spot is. How good does your pass rate need to be? It's got to keep that in mind. Now, what I've shown is a very, very simple example. It's a very contrived HR chatbot and the faithfulness evaluator. Faithfulness evaluator is great for kind of RAG systems where you know we are going to have some kind of context. If the context is not interpreted correctly, we want it to fail. Great for that. But more likely, you're going to want to build your own custom evaluators. You can build your own custom prompts. You're going to want to maybe get a hold of synthetic data, run that against your system, look at the ways that it fails, and then use that to build a load of prompts. Now, this is a big, complex topic. I could literally spend an entire day teaching you how to build custom prompts for your evals. I'm not going to touch it now, but just be aware these out-the-box evaluators are a great way to get started, but you're probably not what you're going to want in the long-term for your application. You want to start building customized prompts to what your application should do. Also be aware as well that you need this huge data set of inputs. You know, I said earlier, here's 20 different ways to ask the same question. We can solve that by having lots more inputs into our range in our test-driven development. We had 20 examples in our unit tests, but you need a big and very diverse data set of inputs. Think about the kind of things people are going to ask your chatbot. And it's not just inputs you expect to pass. You also need to have inputs you expect to fail. If I ask my HR chatbot how many days vacation I've got left, my test should pass because it should tell me. If I ask my HR chatbot how to make a creme brulee, I'd expect it to go, no, I can't do this. And so I need to build some kind of test to make sure that my HR chatbot is just on task. And then I need to have inputs that are HR chatbot related that would pass the on task evaluator, and then non-HR related that will fail that on task evaluator. So I almost need like two separate sets of tests. These should pass, these should fail. Again, thinking about evaluation of development, these inputs, the assertion should be scored as 1. These inputs, the assertion is scored as 0. Like that. But we need this huge data set of inputs, and we need a huge amount of tests because it's a massive problem space, but that costs money. Well, these evals are run against an AI, and LLMs cost money. So you end up spending a lot of money in tokens. So you need to think about what's the right way to do this. Do I want to run this on every single check-in of my application? Probably not. Do I want to run this as release criteria before release? Yes, though that might be too late. So you've got to try and work out what's the sweet spot for the cost of these evaluations when you test. You can also run these evaluations what's called online. So you run this live as people are using your system to monitor how effective it is in production. Again, that costs money. So just kind of keep in mind there's a certain cost associated with these evaluations because you are calling an LLM. Yeah, if you're just testing 1,000 test cases, not that expensive. Got 1 million traces a day in production, can get pricey. And then you have to think about what makes a good eval. What is a good evaluator? What's a good prompt? What evaluations do you need? How many should you have? How do you know if you're measuring the right thing? And that really is one of those, it depends. This is one of those you need a domain expert to help. For example, if an agent doesn't complete a task but asks for more information, is that a pass or a fail? Classic example, banking chatbot. What is my account balance? Your checking account has a balance of $1 million. Your checking account has a balance of $1 million, savings account has a balance of $2 million, you've got a car loan of $50,000. Or what if it comes back and says, yes, of course, which account? Is that a pass? Is that a fail? All three are right for a certain value of right. So you have to kind of think about what does a pass look like? Because sometimes things like customer service agents, sometimes it needs more clarification. You also have to think about the technical correctness as well as contextual correctness of information. It's a great line from the classic 1980s movie Bill and Ted's Excellent Adventure, starring Keanu Reeves and Alex Winter and the comedian George Carlin. In that, their history teacher says to them, "It seems to me the only thing you've learned is that Caesar is a salad dressing dude." Now, if you ask an AI to tell you about Caesar, do you mean the Caesar salad? Do you mean Julius Caesar? Crossing the Rubicon, the first of the Caesars? Do you mean the whole Caesars as a whole, Julius, Augustus, and Octavius, so on? Or do you mean the Caesar cipher for cryptography? Technically correct, but maybe contextually useless. In a history chatbot, you don't care about the salad. In a cooking chatbot, you don't care about the cipher. So again, your domain expert has to define what is contextual, the right contextual information. So you've got to think about having some kind of domain expert. Somebody's got to help you define these evaluations to make to make them work. So you need somebody who acts as excuse me, as this domain expert to ensure you're choosing the right evaluator out of the box or you're building the right ones. So that's the basis of evaluation-driven development. Now, just a quick note. The tool I was using is called Phoenix. It's free, it's open source, absolutely fantastic. It's made by a company called Arise, and Arise are kind of like pretty much the industry standard for running these evaluations. Under the hood, that information is captured using a thing called Open Inference, which is an extension to Open Telemetry. It's kind of the industry standard for how you capture what an LLM is doing. And Arise are actually the company who make and maintain Open Inference. And they're the usual open source company that, hey, it's open source, it's free, but we have a hosted version where you can pay. So if you're looking at this going, yeah, I kind of need a tool to do this, but you need to make sure you conform to single sign-on and SOC 2 compliance and hosted in our internal infrastructure and all that kind of stuff. Yeah, they have their, what they call AX, which is kind of their paid version. A mate of mine at Arise sent me this basic difference that you can think of Phoenix as like the matplotlib versus AX is the Tableau version. Phoenix is when you get started with, host it wherever you want, run your evals, what have you. But AX is where you run this in production with big volumes and you can get live evals on the things you're doing and alerting. And they've got an AI co-pilot that can help you build customized metrics and customized evaluations and all that kind of stuff. So all the cool hotness is available if you want to pay for it. And there you go. That is evaluation-driven development. So basically, AI sucks. So let's put tests around it to show that it sucks so we can fix it to make it suck less. So thank you for the time. I'm Jim Bennett. I'm all over the internet at Jim Bob Bennett. You can scan this QR code to find me on social or go to linktree, so Linktree, Jim Bob Bennett, and you can connect with me on LinkedIn, Threads, Blue Sky, kind of whatever. If you've got any questions about today, let me know. And I'm going to put all the code of this up on GitHub in the next few hours. So I'll publish that on my socials. So follow me there to find out if you want to get hold of the code. And with that, thank you very much for your time.
Thank you so much, Jim. Wow. That was the best session to close Azure AI Connect 2026. I really liked your approach. I want to say courage, but it's more like creativity than courage. So the balance tends to be a little bit more on the creative aspect of your idea about it. I would definitely try the project and the outcomes. And if that's okay with you, I will share some first impressions and maybe ask some questions.
Yeah, go for it. Go for it.
Yeah, amazing. I believe that with this session we have set let's say the stage or how the future will look like probably sooner than we expect. Thank you so much, Jim, for being with us today. It's been an honor having you, and hopefully we can meet you again in another event or even in person. Are you going to the MVP Summit?
I am indeed. Yes, I actually live just up the road from the campus. So will I see you there?
No. I'm too far, and I have already spent my, let's say, abroad credit since we have a family, a small kid, and all stuff. If everything checks out next year, probably yes.
Awesome. Well, I hopefully see you there next year.
Yes, I hope so too.
Cool.
So I want to wish you a great weekend. Have fun, and again, thank you so much for making us the honor to be here.
Thank you for having me. This was fun.
Bye.
Bye.
That's it, everyone. Azure AI Connect 2026 is concluding with Jim Bennett as our last speaker. A really appropriate, I would say, session for Azure AI Connect. And I like the intro. I like the intro of Jim saying that, sometimes it's not all everything about AI. Let's not do this with AI. I like this intro, and we heard it a lot within our speakers these 5 days we spent together. That shows a great step into maturity, right? The first, time, the first period of excitement and enthusiasm has transitioned into a more mature perspective, right? And we are understanding that never mind the hype, some things are better stay in a process that represents and is efficient for the result that we are expecting. It's not everything about AI, and probably AI is not, let's put AI in everything, to say it very simple. I would like to thank everyone for being here with us. Whether you are connected live and watching the stream or you're watching the recordings will stay online in our channels of Global AI Athens and Azure Innovators Hub. That's been quite a week, full 5 days of almost 25 speakers. Some of them were not able to connect, but that's fine. As I said, we are humans and things happen. But I'm really grateful for this event that it became real. It became real. It was an ambitious goal since I am alone on this. But saying that, I will just say one more time: join our communities, find out about the opportunities for being a speaker, being probably a co-organizer, a host, a volunteer, whatever fits your trajectory and your plans for the future. I'm here to help. I will be more than just your your side friend. Let's say I will be actively supporting you, whatever is your choice. So. If you want to be a speaker, you want to be an organizer, you want to participate in community events and provide your expertise, your brain, your mind, your ideas into the community of cloud technology, Azure, and the Microsoft ecosystem. I'm here for you. You can contact me through our channels, as I said, or directly. You can find my details everywhere in LinkedIn. I'm Konstantinos Passadis, and this is Azure AI Connect 2026. Thank you, everyone, for being here. Have a great day, great afternoon, or a great night, wherever you are. Thank you, and have a great weekend as well.
Join us for Azure AI Connect, happening virtually from March 2 to March 6, 2026.